capacity building and collaboration. So we sincerely appreciate the National Science Foundation's continued commitment to advancing digital capabilities in Sri Lanka's agriculture sector. I also extend a warm welcome to our Dean, Professor G.Y. Jayasinha, of our faculty, whose leadership, guidance, and continuous support have been invaluable to the planning and successful of this workshop. Most importantly, I extend a special and sincere welcome to Professor Athula Ginige, Professor of Information Technology at Western Sydney University, Australia, and our main speaker and key resource person for today's workshop. Expertise of Professor Athula Ginige builds the foundation of our workshop, covering topics from the fundamental concepts of digital agriculture and agriculture-centric computing to advanced applications, artificial intelligence in agriculture. Dear sir, we are honored to gain insights from your expertise and experience throughout this program. I also warmly welcome our distinguished guest, head of the departments, our academic staff members, students, and all participants representing various institutions and organizations. Your presence here today reflects our shared commitment to advancing agriculture through innovation and technology. As you all know, global food security is one of the most pressing challenges of our time. So we require innovative, inclusive, and sustainable solutions for that. While agriculture has achieved significant gains in productivity, it has also placed considerable pressure in ecosystem. Underscoring this need for smarter and more efficient approaches are very important. Digital technologies such as data-driven decision-making, artificial intelligence, and precision farming offer a powerful tool to transform these agricultural systems. I think as academics and also professionals in agriculture sectors, it is our responsibility to lead this transformation and to build resilient, efficient, and equitable agri-food systems capable of addressing challenges we have never faced before. In response to these emerging needs, we are currently revising our academic curriculums in our faculty as well to better integrate digital technologies, ensuring that the next generation of agriculture professionals is well equipped to meet future demands. While learning about these new technologies is important, their practical applications is what delivers real results. So I believe this workshop will be a valuable opportunity for all of us to explore and apply these technologies to real-world agricultural challenges. So I encourage all participants to actively engage in this today's session, share your ideas and experience. There may be some group activities as well, and make full use of this valuable opportunity to learn and build meaningful professional connections and future directions. I am confident that by the end of the day, you will leave with the practical insights and actionable knowledge that will significantly enhance your capacity in this area. Finally, I wish to express my sincere appreciation to National Science Foundation for their valuable collaboration and continuous support. And I also extend my heartfelt thanks to the entire organizing committee and all contributors who worked tirelessly to make this workshop success. And especially, I would like to acknowledge and sincerely thank Professor G.Y. Jayasinha, coordinator of the Fountain Project, and also our Fountain Project team for their significant contributions and dedication for this initiative. Once again, I warmly welcome you all and wish you a productive and successful workshop ahead. Thank you.
Thank you, Madam, for that gracious and inspiring welcome. And it's my honor to invite Senior Professor G.Y. Jayasinha, the Dean of the Faculty of Agriculture, University of Ruhuna, to share his address. Over to you, sir.
Good morning, you all. And Professor Athula Ginige, the resource person, and all these members from the NSF members, and all fellow academics and dear participants. So I think these digital technologies in agriculture workshop is timely because now agriculture at crossroads, and we recently witnessed that a lot of challenges. One is the climate change, and as well as we have a lot of labor shortages, and our GDP contribution around 7 to 8, but 25% of so the people are working on that field as well. And again, we have less resources, and with the population, we need to increase at the rate of 40 to 60. Then we need to utilize these resources efficiently, right? So that is where now we need to adapt these digital technologies as well. And not only that, this is the digital era. Even a lot of countries moving towards the digital transformation. So I think this is high time with capacity of this part of this Sri Lankan context as well. So then how are we going to transform this one? Now tools there, how we can transform that one. As the universities, so one thing is we are teaching right now. So how these teaching tools, so the digital blended learning. And we had this classroom, conventional teaching and all these things. Now we are thinking about moving towards this digital incorporation. And then the research. I think a lot of fellow here, I can see NSF grants holders here. So how much they are incorporating these digital, that is IoT. Sometimes you can go with these digital twins and remote sensing, data analytics, data-driven stuff. So I don't know how much we are doing. We are doing just normal research and publications, abstracts. Our index is good. We are happy, but country is unhappy. Right? So we have a lot of credentials and all these things, professors, senior professors, so-called harangues behind us. But country, now we can see about even the president of the country telling there's a problem of the data. Right? So what are then transforming the research with the digital inclusion. And third one, how we are transforming, how we are moving towards the stakeholders. Now normally we are getting, some researchers and we are ad hocly giving. We are not checking with it site specific and zonal one, agroclimatological, right? Now we can see again this forecasting, weather forecasting. There's a debacle that 12th they are mentioned, now the government telling another one. So there's a real discussion on that one. So therefore we have to think about this transformation. Third one, how these faculties, agriculture, universities, how they are working on this one, how they are, how they should move. So right now, Faculty of Agriculture, Ruhuna, so I think our CDC members here, Curriculum Development Committee, so we are given a full priority to make that. I think our secretary also there, Dushan, so they will explain during this workshop, I think. So that is where we are fully, go with this digital incorporation. AI in the business, they are getting this digital incorporation, and they have going with a lot of surveys or need assessment, where to add and how these assessment rubrics, and as well as teaching methodologies, and then getting these, practical stuff, getting the industry in. So that is where we are talking about. Always I'm telling you, sometimes 2-3 days per day. So we had conventional universities teaching
Recording
and
in progress.
Now our guys are moving with this entrepreneurial stuff. That is where we can get the industry stakeholders in and moving forward. And again, now we are thinking about moving with this our curricula with this living lab here, like our field activities farm. Therefore, we are thinking to add. I think our a lot of academics here, so they will definitely experience this one. I have seen these different sessions. I think timely matching that one. And again, we have to have a culture that we are doing research and all these things, go to the stakeholders, farmers and industries, and working towards the country requirement as well. And the next one about how we are placing that now, theory, research, practical. So in that sense, as we mentioned, we have a lot of research papers, abstract and all these things. Now we have to get this, practically how to incorporate these things with all regional and as well as global best practice as well. That is why Professor Athula, renowned scientist. So without, only we cannot do that. So our expert, and then NSF, thank you very much for giving the help in hand. So that is where I had a discussion with these, senior scientists, NSF, though they are working with these, database with the expert and getting their support. That is where we need collaboration, university industry. So that is what we are talking about from the word go last couple of years as well. So therefore, very timely, and thank you for this Avanti and the team and the fountain members for giving this support to conduct this one. And last message to the participant: be curious, not cautious. Be curious and dig to the bottom and get as much as possible, practical aspects. And, all the time make networking, linkages, teamwork, as always I'm mentioning, teamwork. And we are, yearly, I think one member, maybe 10 to 15 workshops they are attending. Don't make this as a mere workshop. At the end, look back and check what we have done, what is the take-home message, and do, productive workshop as well. And once again, Professor Athula and the team and NSF and all the members, thank you very much. So this is not the time to talk, and have a good and pleasant workshop as well. Thank you very much.
Thank you, sir, for your inspiring words and underscoring the importance of this significant initiative. And I would like to welcome Dr. J.G. Shantasiri, the Additional Director of National Science Foundation, who will be joining us later today. And it's now my honor to invite Dr. B.M.S. Jinendra to deliver the citation of our keynote speaker, Professor Athula Ginige. Over to you, sir.
Right. Very good morning, ladies and gentlemen. Professor Athula Ginige, our esteemed resource person, and Mr. J.G. Santhasri, Additional Director, NSF, Ms. Tilina Kumari, a Senior Scientist, NSF, and all the members of Professor Athula Ginige, and Dean Faculty of Agriculture, Head of Departments, members of the academic staff, and all participants, ladies and gentlemen. So it is our great honor and privilege to introduce our resource person today, Professor Athula Ginige, a distinguished academic and international respected researcher in the field of information technology. Professor Ginige is a professor of information technology at the School of Computer, Data and Mathematical Science, Western Sydney University of Australia. He is also an active member of the Translational Health Research Institute of the university. His work bridges technology, health, sustainability, and community well-being, reflecting strong commitment to apply digital innovation tools to solve real-world social and environmental challenges. So Professor Ginige completed his first degree, BSc Engineering with first-class honors at the University of Moratuwa, Sri Lanka, and was awarded the prestigious Cambridge Commonwealth Scholarship in 1987. So he obtained his PhD in computer vision and robotics from the University of Cambridge, United Kingdom, marking the beginning of an outstanding international academic career. So prior to joining the Western Sydney University in 1998, he served as an associate professor and head of computer system engineering department at the University of Technology in Sydney. He also held several key academic and leadership roles there, including head of school. So with over decades of experience in higher education and applied research, Professor Ginige has made pioneering contribution to vast areas of research, such as computer networking and information systems, web engineering and multimedia systems, e-businesses and digital transformation. So his research had significant impact on domains including health and agriculture and sustainability, and application for smart technologies for social and environmental challenges, and empowering community through context-aware and intelligent systems. In addition to his research and teaching excellence, Professor Ginige has made substantial professional contribution to the global academic community. So he has served as editor-in-chief in the International Journal of Advanced in ICT for Emerging Regions. He is a guest editor of IEEE Multimedia and also associate editor of International Journal in Web Engineering, and also served as a member of several international editorial bodies. So his work is widely recognized for advancing multimedia and hypermedia engineering, particularly in the context of emerging regions. So today we are privileged to benefit from Professor Athula Ginige, so his vast experience and deep academic insight and visionary presence of digital information agriculture in sustainable development. So ladies and gentlemen, please welcome Professor Athula Ginige. So, and may I kindly invite you to commence the session and enlighten us on digital technologies in agriculture. Thank you, sir.
Good morning, everyone. And thank you very much for the kind introduction. I'm very happy to be here. I think the context was nicely set as to what we want to do. We have a lot of challenges. Our research cannot be just a statistic in a database at the end of the day. We have to make a change. And it can be done if we all work together. And I'm very happy to share my experience in the digital agriculture field for over 12 plus years. And at this point, I also like to acknowledge NSF, not only now, when we first started at University of Colombo, they also helped, through University of Colombo, helped us to get started. And I'm happy to say we have come a very long way, even to the point, one of my PhD students came from India, Venkat, who is here, we'll talk to you a bit later, is now planning to take this to India, which will start from next year. So what we have developed together with University of Colombo, University of Ruhuna, Kalania, Uvavellassa, now is coming to something very powerful and also is finding its way into India and then to the global south. So within that context, let me introduce what we plan to do today. So we are going to talk about digital technologies in agriculture. We are going to talk about digital agri-food ecosystems, which is going beyond digital agriculture as well. As mentioned, I'm still working, professor of information technology, but going into next year, they got me out of research and said exactly what you said. We have to even change education there, and I have been asked to be the director of research, but to change the whole process. So the program, roughly what we were planning, and I think, sorry, I was a bit late to get in, but I think we make it up. The first session presents some key ideas, but I will show exactly how to use this. Key is for you all to participate. As we progress, we have two options. One is we can break into small groups, discuss and come and report. Some are here and some are here. And I like what you said. At the end, you all can say what you are going to do differently. And that means what change has happened. Because that's the most important thing. We can talk, we can give lots of information, overload you with information. Unless you decide to do at least one thing different, there won't be a change. And I think it's very clear from the addresses I heard, it's time to change. There are problems to solve. But we have research papers, but the problems are still there. Something is wrong. So it will be an interactive session. I'll tell a bit about what the work we are doing. Then you will hear from people who are actually doing it. My research group has put a video together. I'll play it. It's about 10 minutes. I have been doing work with Professor Lakmini, Professor Indika. They will share another 10 minutes of how they are using this technology in their teaching. Then I will invite my PhD student Venkat, who is very much into uplifting Indian farmer communities, modernization, taking technology to the rural village, just to learn what is happening and why he is. You will ask him the question why he wants to do a PhD now, who coming to Sydney when he has done all this in India. So with that background, we will just discuss. What do you think? What can you do differently? And especially, I believe there are some students as well. Am I right? Research students? Yes? I like to know what they plan to do after this. So where are you going to apply this knowledge? Why are you here studying? What change can you do? We'll ask that question. And then after lunch, I'll again give an introduction to AI. As you all know, it's changing. And then I have another PhD student, Ruhuna, over here, came from Australia, but from Peradeniya originally, the graduate. And she will show how the way the research has changed and the tools, AI tools, that is being used in the day-to-day research. Then I'll bring it all back together and talk about the new era that is emerging, which is the fourth wave. After that, we have a lot of time to ask questions, dig deep, and we will explore what you can do when we show what can be done. So that's the day's plan. Everyone happy? Right. As outlined at the start, we have a lot of problems to solve. Yes, we do wonderful research. We go to conferences. But these problems exist. 820 million people go hungry. Climate change is on us. Supply chains are fragmented. And how can we solve these problems? Hidden hunger. And actually what inspired this whole journey was this observation when we were here once, that there is overproduction. Farmers spend their life, but they can't sell it. That was 12 years ago, and we started finding the solution, and this is the journey we have taken. So what the digital technologies can do to feed in this growing population in spite of all these challenges. So in digital opportunities bring us Internet of Things, where the IoT, sensors, all that. We have the new thing, the artificial intelligence. We talk about big data. What does this all mean? Beyond research, what does this all mean? How do we convert these solutions to we have to look at finance sustainability as well, because at the end, we can do projects. When the project funding finishes, project disappears. So that's not going to help. That's why I'm very big on sustainability. We have to look at the economic value. What value can these solutions create? Why should a farmer use a mobile app? Why should someone else use another tool? What is the value? Who is going to pay for these added values? Because we also have a mindset, okay, government should give us funding, project funding, no funding, we can't do research. But is that the right way? If we are producing something of value, there has to be a way to get that funded. So we need to think of those economic terms as well. And then how do we capture that value? Well, that's a very interesting challenge, which we will explore a little bit more. Now, new possibilities. Again, we know about 30, 40 years ago, there was a major scarcity. This whole green revolution happened, especially in India in a fairly big way. But that is when all the chemical fertilizers, productivities, everything came, the harvest went up. But then we are also seeing the consequences of that. The land, because of the chemicals, the microbes have died, land has gone barren, yields are coming down. We had an issue of, I don't know whether it's proven, the kidney issue linked back to all the poisons being put into our food systems. So we had all that. And the question is, to me, before all, still, our ancestors were growing and manage all these pest and disease issues. They also managed the wild elephant issues because when they had the chain, there was another strip for the elephants. So that whole thing is lost. We went in for monoculture, where we lost the biodiversity. So this is where we just went into very technical solutions without looking at the big picture, and basically we are paying the price today. But if you come to this, the precision agriculture, which was mentioned, we have soil maps, crop conditions, soil conditions, all that data. Then they are interpreted into what nutrients, what treatment is required, mechanized application, and then we can minimize the use of pesticides, etc. And later, Venkat will share some of his vision, where now the drone technology is coming in a big way. So a lot can be done here. Then, with the digital technology, we can get this big data. And with that, we can make a lot of informed decisions. Once I went to a farm in Australia, Western Australia. They are growing wheat. Farm size was 3,000 hectares. How many people do you think we need to manage a farm of 3,000 hectares? Any ideas? If farm of 3,000 hectares, how many people do you think they will need? 100, 200, 300? Can anyone give me a number? Sorry? Yeah. Yeah, conventionally 500 plus. Yeah, it was 6 people. 3 agronomists, 3 mechanics. The tractor, they put the right tools, GPS driven, go and plow it comes back. They put the equipment to put the seeds. It goes, put the seeds. And then fertilizer is all programmed depending on the soil condition. The NPK, they are in 3 different buckets. They get mixed to suit the conditions. Drones monitor. The tractors go and bring the harvest back. So 3 agronomists to control that and 3 mechanics will configure the tractors. So that, what have I done? What happened? So that is the smart farm, and it's there, it's existing. Then on the supply chain side, because it's not only the cultivation, we have to get the inputs and the output, the harvest has to go to the market. So we have various technologies to monitor the supply chains, cold storage, the thing we can put barcodes, or store all that in blockchain. So we have a lot of technologies. And they are in use today. Yet, as mentioned earlier, by the Dean. What is our progress towards the very important problems? I mean, this is a sad story. We are only about 17% in terms of achieving SDGs at this point. We have only 5 more years to go. And more importantly, fair bit of it, 33% of that has stalled since 2015 for the last 10 years or gone back. And that is, if you look at the Sustainable Development Report of this year, that's what you find. A very, very sad state. Why? So the question is, have we been using digital technology optimally? Though we are doing all sorts of things, are we doing the right thing? We can do a lot of things. If we don't do the right thing, we'll be going round and round without progressing towards our target. So that's the big question we need to think today. What is that right thing? Now, we are looking at, when we say digital technologies, the intersection of computing and agriculture. And on computing side, we have data science, computations, architectures, knowledge systems, agri-food ecosystems. We can have all sorts of systems that we can develop. Then from the agriculture side, we can look at what needs to happen at activity levels. That is putting fertilizer, doing the irrigation. They are all activities. They are very important activities. And then when the activities happen in an organized way, we have a process. So a process is where you plant a seed, few months later you have a harvest, but in between multiple activities have happened. And then we have the system level. How all these processes, cultivation, supply chains, all work to ensure food security. That's the system level thinking. So on the agriculture side, we need to look at activity level, process level, and systems level. If we only concentrate on activity level, some IoTs, opening and closing of the water supplies is good, it's efficient, but it won't solve the big problems we have to solve today. So we'll explore how we can understand what needs to happen in the agriculture domain at the 3 levels with the target of achieving the first 3 sustainable development goals, which is no poverty, zero hunger, and good health and well-being. Now, what is computing? If you look at computing, it has 5 basic processes. There are 5 building blocks. Input, capturing data, soil moisture, could be sensors, drone images, various farm apps which provide data. Now with that data, the next block is processing, with performing computations and applying logic. If this and that, if the soil moisture level is below this threshold, open the valve to irrigate. So we have the logic and the computing, calculate a fertilizer dose, generating NDVI indices, so all those are computation. Then we have another block called storage and retrieval, where information is stored and you pull it out. It could be a database, it could be a graph database, it could be a knowledge base. There are different variations, but that is where information is stored for future use. Then transmission, we have networks. If it is the sensor networks, it could be something like LoRa, long-range sensors or Wi-Fi's or mobiles. We have the sensor networks to connect all these building blocks, and then the output is presenting information or driving a physical action. Either you see it on a dashboard or control a drone to go and spray. That's the output. So we have this five building blocks. Now the trick in digital agriculture is how we combine these blocks into different configurations. Because the basic level is the activity level, digital support for specific farm activity. Example, a sensor input, sense data transmission to an app that calculate processing and display the alert. So basic level, straightforward process. But then we can combine those blocks in more complicated ways or more complex ways to orchestrate activities in a coherent digital workflow and services. Example, a digital knowledge ecosystem combines agronomy data, weather forecast, farmer inputs into a context-specific crop calendar. Now, it needs a lot more computations. It happens over time. Then, if we go to the next level as a system, how we connect these building blocks, say, and the goal could be to ensure food security. So, these questions, can we connect these building blocks to ensure food security? So, the digital agriculture, or the way we use digital technology in agriculture, is to figure out how we combine these building blocks to achieve things at the process level and the system level. Activity level is fairly well understood. That's why it's required, but I'm not spending too much time because it's well understood. There are so many books you can read, but what is not well understood is the other two levels. Any questions so far? All good? So let's look at this from a system point of view. Because agriculture is a complex domain, very complex. I mean, when we started, we thought it's pretty simple, but when you start to understand it, it's very interesting, but very complex. There's no straightforward solutions here. At a broad level, we can identify three subsystems in a whole food supply chain. In the middle, the main thing is the food production. That's where the farmers decide what to grow, when to grow, how to manage it, and get a harvest. But for them to do that, there is the input subsystem. It could be the inputs, fertilizers coming on time, or it could be the services. I have bundled all that into one. Could be hiring of tractors, the drones, or it could be the extension officers, the support. All that is going into this subsystem, which we can break into different subsections if we want to. Then the harvest, when it is ready, should go into the markets. If any of these systems is not functioning in a coordinated way, we have problems. And when that breaks, we see overproduction, waste. We see low yield. It could be a short-term issue, or it could be a long-term issue. We see excess poison in our food. So the thing is, we'll need to balance these three systems. Now, this is the tricky one. We can't predict the yield. It depends on the weather. It depends on the pest and disease attacks. It depends on the funds to buy the fertilizer, whatever required at the correct time. Governments try to manage this through various policy incentives, price guarantees. So you can see at a complex level, we'll need to balance all that. And this whole probabilistic nature of the cultivation side is what is creating so much challenge. But the thing is, the good thing is, digital technologies can even address that challenge, and I'll show you some examples. So as I mentioned at the beginning, it was in 2011, we were at University of Colombo, few of us, and was wondering, the technology is growing. We are coming from computer science, robotics, computer vision. What is a good problem to solve? And at that conference, we had people from Sri Lanka, Australia, USA, Italy, and we were discussing, and at that point, Professor Jeevani, he's in UCSC, came and said, look, there is a problem. There is all these tomatoes. Why can't we do a supply and demand balance? This is the early stages of mobile. Let's explore. Everyone said that's a good problem to solve. And I have to say, or no, I should not say that. That was an interesting name for this project on the early days within the internal circles. But the picture will give the clue. But from that we started. We looked at various challenges. I'll cut short and say, after 4 or 5 years of research, that's where we had, again, help from NSF to conduct this research. We came up with a cohesive intelligence system to address the challenge based on 5. One pillar was a unified ecosystem concept. These are all ended up, 3, 4 ended up being PhDs, 1 was a master. So that was the level of thinking and time it took to solve it. So unified ecosystem, it was Dr. Lasanthi from UCSC. The knowledge repository, how we organize the knowledge is Professor Anusha, one of your faculty members, did her PhD on the system way back then at UCSC. Empowerment framework, how we give information to farmers in a way to empower the farmers. That's Dr. Tamara, she's sitting here. She also is my wife, but she got interested at Macquarie University in Australia. She did her PhD and brought her knowledge into this. Context modeling was one of my master students, looked at how we categorize the knowledge required at different stages of the process. And the other one is, through a mobile interface, how do you communicate that information to the farmers in a way where there is least resistance? Because I can still remember, we did some design, and throughout we worked with the farming communities, and when we showed those prototypes to the farmers, they start to touch the phone. Guess what? Their fingers were very rough. We were expecting this nice touches, small buttons. No, it won't work. So we learned quite a lot. But it is through practical applications and went and changed the interfaces. But what we found was we can create information flow map to connect all the key stakeholders. Starting with research institutes, that's way we can get that knowledge. We can digitize. And it's not databases, it's ontological knowledge bases contributed by Professor Indika in her PhD work. Given to the farmers in a way they can be empowered, contributed by Dr. Tamara in her PhD work. And then, because it's given as a way to empower, which I'll explain a bit later, we get feedback and we figure out how to generate market intelligence. That happened much later, where we did a major project with Anand Agriculture University. Have you heard about it? A major agriculture university in Gujarat. They got World Bank funding, and we did a major project and did quite a lot of work here. And were able to predict the supply, demand, that type of information that then can be fed back to the institutions, but can be used to connect the supply chain. Was our foundation based on this ecosystem flow map. And today, since we have been running this constantly for the last 4 or 5 years, all the farm actions we have collected, and we have millions of data points where we have now started data analytics, AI, to algorithms, and also the people who are working in that team are your own graduates who have graduated and now working in those analytics work. So it's pretty much actually, over time when I look back, the Ruhuna students have contributed quite a lot in building this system. Now, first thing is I showed the whole ecosystem, the knowledge path. Now, how do you store this information? What questions we ask? A farmer wants to know what crops will grow in my farm. So what is my farm? How do you interpret the my farm? So my farm has a location, could be agroclimatic zones that was mentioned. From that, we can get various soil type parameters. If we organize the crops, it has varieties, but it depends on particular environmental factors. And if you match these two, we can answer the question, what will grow in my farm? So you can see how those digital blocks can be connected to answer that questions. And I'm not going to explain the same model, but if you extend it to how you manage pest and disease, it was done. And it was done by Professor Indika. And now it is getting extended further with AI. And it is done by one of her students doing a PhD with me in Sydney. Then if you come to the environment-based processes, again, the key thing is need to understand how people make decisions. They have a goal. They have certain internal characteristics, interpersonal components like competence, sense of control, motivation, self-efficacy. When they have a goal, okay, I want to get to maximize income. Based on that, they execute the behaviors. It could be identifying choices, decision-making, autonomy, engagement, communication. In basic characteristics, they'll display these behaviors. As a result of that, and then over time, from the environment, they will get a feedback. It may be they decided to grow carrot, and by the time they sell it, prices were good, so they were happy how they made the decision. But we know the reality is by the time they try to sell the carrot, everyone has decided to grow the carrot because the price was high at that time. The glut prices crash. But key point here is farmers need to be given a choice and they need to understand the consequences. Then they will experiment and figure out what works. Now to do that, on the other side, we can use our computation to support that process. They can ask what crop to grow, use a query. We get the context filter, we can get the coordinates today. So we know the location of the farmers. And go to the ontological knowledge base, and it will say these crops, actionable information, these crops will grow. Then they can ask more questions, and they can decide I'm going to grow 2 acres of bell pepper. Now that gets captured, and we know in this location in Mathara, 2 acres of bell pepper is grown today. And all that information get aggregated. So we have a situational awareness what is happening now in Sri Lanka. And then, next time, when there is a question of someone trying to grow bell pepper, we can even indicate, look, there is so much bell pepper is grown. Why do you want to still grow bell pepper? Here are some alternatives. That's how we can think of balancing supply and demand. Now, those were the early research, but we have now extended it to the whole supply chain, and many more PhDs are happening. And in a later session, instead of going into all that, it will take me months if I'm to explain. I'll play a short video they have prepared for you all to get an idea of what can be done. Then what happened was, we were doing this project with Ruhuna during the COVID time with a head grant. There was a request to say, look, can we help home gardening? So we deployed the home gardening app, working with the team here. But then from our university side, there was an issue. All the funding has to be freezed. No one knew what's going to happen early days of COVID. But then I said, look, I have a problem. There are people using these apps, and what can we do? They said, okay, the best thing is we'll help you to start a startup company, research spin-off. So with that, in 2020, we formed a startup company called Vidya. Again, you can realize the name represents knowledge. Because to do anything, you need to have the knowledge. So that's how the Vidya was born. And we have a launchpad, incubator. I was given 6 months and said, go and now learn about business. So I'm very happy to hear the entrepreneurship, etc. I went through that journey. I can also talk the entrepreneur language now because of all the training I got. But it's a must. We experimented with, these were our early mobile apps, which we started. This is what we got actually with the NSF funding. This is the early versions. Then we actually tried something in India, in Telangana, and it evolved some more. Then we did another project together with Heart, Pest and Disease Management. But again, with COVID, halfway through, we had barriers, we couldn't complete it. But we kept the home garden app we started, which now has evolved into a full-blown commercial app, which is called Govinana. And we still call it Vidya Ruhuna Govinana in recognition of the contribution made by this Ruhuna University. And now we have many more apps, and it's evolving. So that's a short history, but that's the technical, that's the business side, but also the entrepreneurial side. All needs to blend in order to find a solution. So this is how the ecosystem now works. We work with, that's knowledge partners, that's the universities, the Department of Agriculture, that's the farming community. We have the input suppliers. Also, we did a use case in Maharashtra with a major water authority providing irrigation in a canal. And on this side, the harvest buyers are there. So the question is, how do we connect all of them? And I showed you the 3 wheels. How do you make those 3 wheels work in a synchronized way? So we start with knowledge partners, digitize the knowledge, crop knowledge. It came from books, it came from DOA. Professor Lakshmini helped us a lot with the crop knowledge, checking what we are coming up with. And then, in our technology platform, we convert that knowledge into actionable information. It's like a GPS. If you have ever tried to drive using the printed map, it's not easy. You have to look at all this context. Okay, what can I do? What can I do? Same information in the GPS. When you are at the junction, it says turn left, turn right, go straight, actionable. And if then later, when there's many people using the GPS, it will say, aggregating all the traffic data, okay, this is the shortest, but this is the fastest. The next level of intelligence come into play. So similarly, here we convert into actionable and give it to the farmers through the mobile app so that they can act. So that action comes back to the technology platform. And we get 3 critical data points here. What they are growing, what is the land area, and when they planted. Moment you have these 3 data points, we can do a lot of computations. What is the expected yield? When the yield will be ready? What inputs are required? When the inputs are required? And if there's a water need, when that water will be needed. And more importantly, what harvest we can expect and when that will happen. Now, once we have it, we can make those available to water suppliers. That was the project we did in Maharashtra. We can provide it to people like Haley's, etc., because they can optimize the input supply chains. We can then provide it to the buyers so that in advance, it could be the buyers, it could be the government, to plan what is the predicted harvest. Actually, recently I was watching a video, and I think it was the president who was saying, we need a way to predict what is being grown accurately in order to decide. I think the hoteliers wanted to import fresh vegetables. That was the, if I remember. But obviously the officers didn't have a way to say what is available or not in real time. Now I'll show you, we can generate that map in real time today. And when it's there, they can even go into contracts with the blockchain type technologies. The water can flow, the inputs can flow, and after the cultivation period, the harvest can come to the buyers. And the money through blockchain type technologies can go back. And in Lanka, I'm very keen to explore how we can connect with GovPay. Actually, I'm trying to meet with ICTA on Monday to explore that possibility. And then that can go to farmers in a more secure way. They don't have to take risks. Can go to input suppliers, water coordinating authorities, and even to the knowledge providers, the researchers. They should get for their effort. That's why I said, like, don't rely. You need some funds to get started. But if you think outside, this in the ecosystem itself, if you are creating a value, something should come back. We have to think along those lines. So that's how the whole ecosystem now works. So this is the Govinana mobile app in the current form, because it has evolved and there's a new version coming probably next year. But we constantly keep developing it. You can add crops, look at weather. It reminds you about your activities, what to do. Then if you have multiple farms, you can have farm-related information. Then there's a community module, and I'll show you more about it. There's about fertilizer, how to make vermicompost, all that, which is helpful. But also now we have added a crop care, which is a major area. Farmers said they want information. Now, one of the major things which make me very happy is this: in this community module, people can upload pictures or more like the Facebook or a WhatsApp group built into it. And one day when I was looking at it, I saw school children are growing using the app. Now I can see the way how it connected to the next generation. That was about a year ago. And then I understand the parents come and do Sramadana. And the thing is, yesterday I was trying to get a picture in time. when this happened, Department of Agriculture Southern Province actually organized a school competition. And they select, based on this work, 3 schools, 1, 2, 3. And yesterday I had the honor of giving the certificate for the school that came first. And we said, look, we will buy you the agricultural equipment worth 50,000 rupees, which has been organized for them to. The head principal telling us, yes, now they grow across the road. They also run a shop in the morning. And actually, it's the parents again buy. That money comes to the children to buy their school books and study. So once we start to think outside the box, here are the case studies. What can be done? The knowledge came from the universities, went through the app, school children started using it, learning it, also finding their pocket money for their education. That's how it links. And it's progressed a lot. And gold medal for Vidya Ruhuna Govinana Farmer mobile app at the RIEE 2024 competition. And you will be recognizing some of the people behind this who worked to make it happen. But we have over 3,000 users today, 176 agriculture extension officers from Southern Province, 439 crop varieties, 51 crop list, information on 250 pest and disease things, and more importantly, that map I'm showing there, I can generate it in real time as to what is grown in Sri Lanka today by the people using the app. So if you have that capability, you can do a lot more. Supply and demand balancing, or even in the case of current floods and the unfortunate situation, if we have this map, if we mark the area in this map that got destroyed, we can immediately compute what is the balance harvest. Just subtract, because we know the 0 points. We know where it is. So these are possibilities with digital agriculture. The other thing that has happened, which we'll talk a little bit more in the last session, is getting that crop knowledge has all been now streamlined AI tools. So we can input, could be the published research paper, the books, and we extract again using into a knowledge. One key thing is we don't 100% trust AI. AI can make mistakes. So this information then go back to the experts. But it's much faster for them to validate, check it, than trying to write it from scratch. That's a huge difference in time. They change, they modify. Once it's validated, we put it into the final knowledge graph. And then users can ask questions, or we give it through the mobile app. So this is an example where we are using AI pipeline, and we are refining it and enhancing it at the moment. Again, we have a team. One of them is, again, from computer science faculty here, working on that pipeline enhancements. Now, so you can see how we can provide the information to the farmers, how we generate, use AI, how we empower them. Now, the next key question is, how do you the market? I mean, there are many like they try to do it, it failed. And there is a fundamental reason which we understood through research. Agriculture production is probabilistic. Supply chain side is deterministic. Therefore, it's very hard to assess the reliability and the value. And we have to think beyond that traditional way to do this. Say, for farm, if they put some fertilizer, in the output, they cannot say this is the fertilizer. Maybe they have fertilizer, there was a pest or some drought, and the harvest is very low. But if you look at some mechanical thing, making a chair or manufacturing, if 5 or 6 bolts go into in the output, you can say these are the 5 or 6 bolts, and therefore this is the value. But here you can't do that. So we have to recognize that major challenge. So creating sustainable agri-food systems to feed the growing population, that's the bigger goal. Digital technologies has the potential, but how? The unknown. Poor adoption, and as a result we see, though very little of this technology being adopted by the farming community today. And the reason coupling probabilistic production with deterministic supply chain is the challenge. At a conceptual level, at research level, here's a good research problem to solve. So if you look at it, probabilistic production, deterministic supply chain, and when this is not coupled, overproduction, price fluctuations, waste. That's what we see. And what we know is on the digital technology side, the supply chain side, there is a very good adoption. If you look at Keels, Cargills, they are using quite a lot of digital technologies. But on this side, there's very little. And what they do is they have agents going to the farm and inputting, it won't scale. A lot of inaccuracies is not the optimal. So there's a high adoption on one side, the poor adoption on the other side. Now, if we can connect the two through a digital technology platform, we can solve this problem. And what we found, it can be solved by looking at it as a value flow. And for the value flow, between two people, there has to be, but when you mark the transaction cost, those who are doing agriculture will know. Now, if digital technologies we can use to minimize the transaction cost, more we minimize, we can enhance the value flow. Now, to minimize, there's a search cost, trust building cost, all that. That can be modeled as a material flow, a money flow, a knowledge exchange, but also two types of trust. Trust in the party, trust in the ability. Because if there's no trust, nothing flows. The beauty is, this is digital, reviews, ratings, rankings. Material flow can be coordinated digitally, timing, scheduling. Money flow is digital, GovPay or blockchains. Knowledge exchange is also digital. So if you look at the digital technologies, all this either can be done or enhanced through digital technology. Beauty. So we looked at the whole value creation process. So we looked at this as a value creation process. So if you take our app, there is cultivation guidance, social learning, which I showed, how they share information and learn one another, and market access. And if you look, we provide the right information, weather information. Social in the community module, which I showed you, where they interact. And for market access, for the farmers, the value is in selling. And with our data, for every farmer or every user, we can identify in each of these modules when they access the app, because we have granularity of data. So he is not a very active user. Here is someone who is looking the community module practically daily with some other activities. So we have, again, that's where the data analytics come. We can classify different types of users, their behaviors, all that is getting studied. So once we start to look at it, we can then look at what the value farmer gets and when from each of the modules. Social learning, it happens practically throughout looking at it. Cultivation knowledge from planting date to harvesting date is useful, but then in other times, no. But the selling actually is the major one. It peaks closer to the. And the question is how we bring farmers from start to the selling point in an effective way. So for that, we have started developing a market readiness score. This is all Rifana PhD. She's here if you want to ask more questions. And if you look at the app, there's the crop information, crop care, weather, helpful information, and community. And if they select a crop and grow, they get the activity calendar. So that means they keep engaging with it more and more. And since we know their behavior, based on how they are using it, we can start computing a market readiness score. So going forward, the farmers will start using them next year. These scores will be calculated. And from that, we can identify whether he's a genuine farmer or someone just browsing or they're just experimenting. We have those categorizations analyzed now. And if they're a genuine farmer, we invite them to an account. That means we check more KYC identification numbers. To start with, you don't need anything, just the phone number. But if they're genuine and willing to sell, we invite them to open a trading account. And then they will start receiving orders from the buyers. And when they sell, that information will be fed back to modify the score. Again, you can see how digital technologies are used in that whole trust building process. And basically, this is some insights about the engine, how the scores are given, and how they are guided. Again, these are the things that digital technology can do. So the market is going to work like this. As you saw, the agronomy institutes, we digitize the knowledge, give it to the farmers, they grow. And when they grow, we generate this map in real time. And then the buyers will place orders. But when they place the order, based on want, we know farmers will have window. We have analytics engine being built now. It will be matched with the available harvest, and farmers will be given the opportunity to say, look, here is a buyer, do you want to sell? And that is the mechanism we are going to test in the coming 6 months to do the selling process. Now to go to the system. When is the break? Sorry? Okay. From there, if we go to the system level and we looked at this is the we asked farmers, traders, consumers, and policymakers what you want, what's the outcome you want. Certainly farmers want optimal revenue. Traders want to optimize their profits, fair enough. Consumers want the best price, reduced price, and policymakers was to ensure food security, fair distribution. Can all this be achieved? Here's a question. Farmers want high price, traders want high profit, consumers want low price. Can that be achieved? I'll pause here for 1 or 2 minutes. I'd like to know your thoughts. Can this constraint be achieved? This is where we have to bring the creativity. Tell me how we can achieve constraint. Yes, we need a platform, but where can we find some additional money? Because if they want, we need additional money. If they want more profit, we need additional money. If they want less price, that has to be substituted by some additional revenue, additional value. Yes, we need that platform to do that, but where are we going to find that additional revenue? Yes. That's where the trick is in this. We need to reduce the post-harvest losses, and we need to reduce the transaction costs. So that's where the beauty of systems thinking. And can someone tell me about the amount of post-harvest losses that's happening? It's into billions, isn't it? The moment we even start to save 20, 30% of that, it can be distributed among all these people. So that additional value comes from saving the waste. So that's where we have to think at systems level and create the digital systems accordingly. So these are contradictory outcomes. So this is where we solved and we simulated all these models in the Gujarat project, where we have policymakers, farmers, traders, and consumers. So the key to minimizing post-harvest losses is balancing supply and demand. Moment there's oversupply, it's a waste. You can't do much. You can make some jam, you can make some chutneys, but at scale, no. But what happens is, to do that, the government, especially this is an Indian case study, they have this MSP for about 23 crops. They have major problem because they are giving the guaranteed price, and farmers, especially in Gujarat, just keep growing. Silos are full and they go waste. But if you put the price without looking at the demand or just a fixed price, this is going to imbalance the whole system. The demand, if we know the population, adjusting for the seasonality, festive seasons, etc., we can have a fairly good prediction. And then when you know the demand and the supply, how do you signal the farmers what to grow, what not to grow, which is an interesting question. And this is where the market intelligence come into play. And then farmers are now producing and consumers want to buy it. We need to have a better market linkages throughout. And also, we need reduce the information asymmetry for the market to properly work. So those are the conditions to meet this contradictory situation. And if you look at this diagram and see the production to a country equals to consumption, waste, and exports. So we are targeting the waste can happen in the supply chain, which can happen due to overproduction. So we'll need to balance that. And the consumer price to the consumer is production cost plus storage cost, transport cost, wastage cost, whatever. If you minimize it, and also all the transaction costs in the intermediary. Now, that is where the platform comes. If we can bridge that and minimize the number of, we need some intermediaries, we need some aggregation. But if we can minimize it, that's the huge saving. So once you start to think of systems level, you can see how we can change. And if you are interested, there is a report they published of it. That was done. And then there's another system level point I like to highlight. Again, this came from another PhD student who looked at during COVID in Sri Lanka. There were initial shorts, but with food, and also looked at the globally. And the key observation is we only think of these large supply chains, which has been classified as M4 or the large supply chains. But what happens is in agriculture, When there is a crisis, the home gardens went up, community gardens went up. They start sharing. Local farmer markets came up. The various three-wheelers, etc., or others collected and reorganized the whole system. In other words, the whole supply chain has to be designed adaptive, which digital technology and policy the major contribution here. And Lasana Flora, instead of flowers, they were delivering food at that time. Because if we have the connectivity, all that can be adjusted in real time. And if you are looking at policy level, this is where a digital technology can play a huge role. So finally, in this session, the bigger vision is if we have a digitally connected farmer community where they see value and use it for food production, in real time, we know what's happening. And that information can be used to generate market intelligence, coordinate inputs, and especially for the governments. If they have that data, they can have from static policy to dynamic policies, which will dynamically adjust. That's the control. We dynamically adjust the supply and demand so that we can balance, minimize waste, and that is where, at a system level, with digital technology, we can get this best value from that technology. I think that's my last slide, yes. So that's a big, quick overview of what we are doing and a taste of what can be done.
A profound thank to Professor Athula Ginige for that enlightening and enriching session. And with that, we will now have a short refreshment break. Please be in your seats by 11. Objectives of this initiative. He will be joined with us virtually. Thank you.
Thank you very much. Can you hear my voice clear?
Yes, sir, we can hear you.
Okay, thank you. Good morning, everyone, and our distinguished resource person, Professor Athula Ginige, and Ms. Tilina from the National Science Foundation, and all distinguished participants. Good morning to all of you. First of all, I apologize on behalf of the NSF and the Director General. I apologize for not being able to line up with the agenda and shed light on the opening remarks as I was expected to present at a meeting at the ministry. Anyway, to keep short and sweet, I won't take much time. On behalf of the National Science Foundation and the Director General, I would like to highlight key points. National Science Foundation, one of the key mandates is connecting our research community, our scientists and leading researchers with the global talent pool for connecting with the global resources and scientific community so that they could harness the cutting-edge knowledge, frontier knowledge, thereby our innovation ecosystem also will be on par with the global stature. So that which will also enable connecting with the cutting-edge R&D, infrastructure, and our scientists, and collaborative research, cross-border collaborative technical cooperation, so which will ultimately foster and advance our local innovation ecosystem. As one initiative on this mandate, we have developed a global digital platform where our Sri Lankan eminent expatriates from the industry, academia, from around the world are connected with the National Science Foundation. Harnessing with this resource pool, we always trying to connect this resource pool expertise with our Sri Lankan research and scientific community, so that cross-border cutting-edge knowledge transfer will be facilitated. So this program, of course, this capacity building program also has been triggered or stemming as a result of that initiative. And I don't want to highlight you the importance of how digital technologies will impact on the agriculture sector. I mean, each and every sector, but of course, why it very important for the agriculture sector? Because I think present government and all priorities the improving the agriculture sector productivity. I think earlier contribution to the GDP from the agriculture sector was 15%. Of course, it has been in a declining trend. Now it almost, I think, almost 9 or even below. So we had to enhance our productivity, capacity, and everything to feed our growing population, and also to while contributing to the GDP, yielding socioeconomic benefits. So therefore, I think that going digital, government also going digital. I mean, government priorities digital economy, government sector, private sector, I mean, service sector, all from the digital technologies, it should contribute substantially to the economy. So therefore, definitely, agriculture sector also shall infuse with the digital technology. In that context, I think this program is very timely, and I have to appreciate the Vice Chancellor, Dean, and relevant faculty of the University of Ruhuna for come forward and partnering with the National Science Foundation to harness this cutting-edge knowledge. I am sure Professor, our eminent resource person today, Professor Athula Ginige, is an eminent expertise in the field, so that my humble request is to get the maximum benefit out of this program. And also, I am sure because universities will be one of key entity taking, I mean, in terms of teaching, empowering with the cutting knowledge with the graduates, and of course postgraduate. Even I know Ruhuna University have linked with the farmer societies, association, so that knowledge could be finally not only to the confined to the classroom or the lecture theater, but of course beyond it, that level, to the even into the farmer level, or the agricultural, entrepreneurial, or the industry sector, I am sure. So therefore, my humble request is today is to take the maximum advantage of this program, and also try your best to from theory to practice. So that's a humble request for ultimately, because we are, of course, this whatever funding invested from the NSF side for this program is actually public funding. So we have to make a justice. Finally, at least percentage benefit shall go to the final end, means transdisciplinary the society or the farmer level. So my humble request is try as collectively so that end of the day, certain digital technology will infuse with the agriculture sector, and for benefit of the agriculture sector, I am sure our agricultural entrepreneurs, farmers will be empowered with the digital technology. As to my knowledge, even African continent going on the digital with the digital technologies with the agriculture, because a huge challenge is in front of us, mainly due to the climate change and unexpected disease outbreaks. Those are very challenging for the agriculture sector. So therefore, could be looking for exploring potential of the digital technologies, early identification of disease outbreaks, optimum utilization of fertilizer, water, and of course there may be many. So that was from the National Science Foundation. Before I stop, I must thank our profound appreciation for our eminent resource person, Professor Athula Ginige, for agreeing to share his wealth of expertise to transfer the knowledge for the benefit of our Sri Lankan research community, and also the organizing committee from the Ruhuna University and the faculty and the dean and the VC for partnering with the NSF to propel the agriculture sector with the emerging digital technologies. And thank you very much. I will stop here.
Thank you very much, Dr. Shantasiri, for clearly outlining our goals and setting the strategic context of our day. Now we are moving to our next segment, session number 2, Bridging Research, Teaching and Practice with Digital Tools. This session will explore tangible pathways from theory to impact. Once again, I would like to invite Professor Athula Ginige to lead our discussion. Over to you, sir.
Thank you very much. And probably I'm not going to talk too much in this session. I'll start with a video to show what our research group is doing. Yes, sorry, the mouse pointer. So I'm going to introduce some of the work done by our Western Sydney University Digital Agriculture Research Group for you all to get an understanding the type of research that's happening there.
Currently, we are 6 HDR students representing Digital Agriculture Research Group, and our principal supervisor is Professor Athula Ginige. Kasuni deepened our understanding of how the agri-food supply chain ecosystem works by analyzing the issues that emerged during the COVID period, and she has now submitted her thesis. Sanju explored how farmers adapt through agricultural extension services and completed her master's degree with flying colors. Ruhuna has been working on the very challenging problem of how to develop clear value propositions for digital agriculture. She introduced the idea of bridging the gap between the probabilistic nature of cultivation and the deterministic nature of supply chains, a perspective that many others have now picked up as it opens a new way of thinking about adoption. We have been joined by Venkat, who is extending our ecosystem work by bringing in drones and drone spraying services that can significantly reduce the cost of production. Shyama is bringing AI expertise to our team. She has been digitizing our crop knowledge and building data pipelines, and we now have chatbot and AI-based crop advisory tools. Samya has been looking at the whole knowledge creation process and has developed a new understanding of how knowledge is created and shared in communities using digital means. Currently, we are 6 HDR students representing.
Let's talk about our global food system. It's an incredible thing, really, a marvel of efficiency. But here's the problem. It's also incredibly fragile. The moment a crisis hits, that efficiency can just shatter. So what's the solution? Well, what if it's not just about inventing more clever gadgets? What if it's really about changing the way we think about the problem itself? Our food systems are built for the best case scenario, for smooth sailing, not for the storms that come with a long crisis. We've optimized for efficiency, and in the process, we've accidentally made our entire food supply brittle. And that leads us to the big question, right? How do we get from being brittle and efficient to being truly strong and resilient? It is a really powerful new way to think about the answer. It all starts with a new way of thinking. This is not about finding some single silver bullet piece of tech. It's about a pretty fundamental shift in our entire approach to solving problems. And at the heart of the shift is this idea, the socio-technical solution. Not just about the shiny new tech. It's about an innovation that combines that technology with the people, the processes, the trusts, and the messy real-world context that actually makes it work. You see, it's all about making technology fit our human systems, not forcing humans to awkwardly fit the tech. First up, let's talk about fixing the flow of information. I mean, how do you get the right advice to the right farmer at exactly the right time? Sandra's work just zeroes right in on this huge disconnect. You've got farmers dealing with a world that is changing faster than ever before, new pests, weird weather, but the systems that are supposed to help them are often totally stuck in the past. So what Sanju did is he developed this simple but powerful diagnostic tool. It helps figure out what the real bottleneck is. Is it a communication gap where advice is just too generic? Is it a resource problem? Or is it a technology barrier? You see, once you diagnose the specific problem, you can match it with the right level of tech. Now, Shama's research tackles this exact same problem, but from a slightly different angle. She asks, how can we make advice not just faster, but more personalized and, maybe most importantly, trustworthy? Her solution is a really smart AI advisor. But get this, here's what makes it work. It's not just some random chatbot scraping the internet. It starts by building a knowledge graph from sources you can actually trust, expert sources. Then, human experts vet all of it. Only then can farmers ask questions in their own language and get answers they can rely on. Okay, so we've seen how this systems approach can help with the flow of information. Now let's switch gears and look at the flow of value. How can we use digital platforms to create markets that are actually fair and sustainable for everyone? Ruhina's research starts with a problem that is super common and incredibly expensive. We've all seen this story play out. A promising new app gets a bunch of funding, it has a great pilot program, and then, poof, it just quietly fades away. Why does that happen so often? Well, she found that for any digital platform to actually survive in the long run, it has to meet 3 conditions, and they're pretty much common sense. First, the farmers have to see a clear, tangible benefit for themselves. Second, that benefit has to be bigger than the cost of using the platform, and that includes the time and effort it takes to learn it. And third, the platform has to make life easier. It has to reduce the friction of doing business, things like finding buyers, negotiating prices, and building trust. The bottom line is, a platform only survives if it creates real value and shares it fairly with everyone. Now, Venkat's work takes a look at a really high-tech tool, drones, and asks a critical question. Why aren't they reaching the small, vulnerable farmers who could benefit from them the most? And this number really puts the whole challenge into perspective. In India, mechanization among smallholder farmers is still hovering around 40 to 45%. That's a massive gap where technology could make a huge difference, but only if people can actually get access to it. This is a perfect example of that socio-technical idea. The platform provides geo-matching, transparent pricing so you don't have to haggle, verified identities to build trust, and secure digital payments. All right, so we've looked at information and we've looked at markets. How do we design entire food systems that don't just survive shocks, but can actually learn and adapt from them? Remember this quote from Kasuni that we started with about how our systems are built for efficiency, not survival? Well, we've come full circle. Now let's look at her really interesting solution. This is such a powerful shift in mindset. We usually think of resilience as the ability to bounce back to normal after a crisis. But Kasuni introduces this idea of viability, a system that can actually transform and thrive, becoming stronger through the crisis. She calls it channel symbiosis. So imagine a crisis hits, and the normal supply chain is totally disrupted. A digital platform could connect local home gardeners with neighborhood stores that are desperate for produce. The gardeners get a new market, the stores get a new supply, and the community gets fresh food. The system didn't just bounce back, it bounced forward. It created a new, stronger connection. But for a system to evolve like that, its knowledge has to be able to evolve too. And that brings us to Samya's research. She tackles one of the biggest barriers to adaptation, knowledge that gets stuck in silos, becoming fragmented and outdated. To solve this, she proposes this cool model of 3 living knowledge spirals. Think of it like this. First, the content spiral. Expert advice is constantly being updated and refined based on feedback from farmers. Second, the platform spiral. The digital tools themselves adapt based on what users actually need and how they use them. And third, the community spiral, where farmers and experts are learning together, validating new ideas as a group. The huge takeaway is that you build resilience by building learning right into the structure of this system, so the whole thing gets smarter over time. So we've looked at 6 different projects, from AI chatbots to diagnostic tools to drone ecosystems. They all seem pretty different on the surface, but when you step back, you realize they all point to one single powerful unifying idea. These are the core principles that come out of all this research. And that brings us right here to our final thought. Technology, the apps, the drones, the AI, it's an incredibly powerful tool, no question. But as we've seen again and again, it's only ever half the answer. The real question, the one we have to ask ourselves, is this: how are we going to design the other half?
Okay, so that gives some idea. Any questions of the research that's happening in Sydney? The type of research we need going forward. Yeah. More than that, how we now embed that technology in the society. Implementation, but understanding the humans and how that technology impact the humans and how the humans can change the technology. So there's a whole new discipline emerging as socio-technical system on looking at the human dimension and human technical interactions, and then how we create the systems for people. Yeah? Because I think earlier it was mentioned about the curriculum, etc. This whole socio-technical system design needs to come in. And we need to test it. Our laboratories are not what is in this building. Our laboratories are out there in the field. I think we'll have to get that mind shift changed, and it can be done. And that's how all these people work, because we get farmer data from here on a daily basis, millions of data points. And I see now Dinesha has joined. Her task is to look at those millions of data points and make sense out of it. Dinesha, what's the degree you did? You didn't do computer science, right? Yeah? Okay. But your degrees? Bachelor of Science. So after that, I mean, she came and we said, okay, here's millions of data points. Tell us what people are doing, how they are navigating, what farmers are doing. Are they a genuine farmer or are they just playing around? And then she's analyzing all that data. So for us, I mean, we sit in Sydney. Some sit here. Some sit in Singapore. But for us, this whole thing is the laboratory. We have to bring it to the grassroots level. You all need to go sit with the farmers. That's what I did yesterday. Morning at Gaul, afternoon in Nakuras. Went, listened, understood their problems, and then say, look, let's solve it. Yeah, it has to be customized to the local conditions, the local needs. And then only we can solve those problems. Yes. Yeah. Yeah. It's that partnership. That's where the socio-technical systems come. In one sense, we need to know what the technology can do. On the other side, we have to understand what the people need, their needs. What's the value? We need to think of values. And the value mapping is one of the big areas we are now doing. And how you quantify the value. So they are all interesting research questions. We need to solve them to solve these problems. Any other questions before we move on to the next segment? Rifana, is it for us to have a Menti question in this session? Yeah, for them to suggest questions they like to develop based on the discussion, which we'll take it at the end if you can put organized. Thanks. Okay, so next case study I want to present is actually from this university. How Professor Deepthi used the system with Professor Indika and got your agriculture students to use it in the farm, Professor Deepthi and Professor Indika. And Lahiru, is Lahiru going to show it or? Yeah, there's Lahiru.
I'll give good morning, everyone. So first, I like to give a brief introduction about this Lahiru's presentation. Actually, Lahiru is going to present you a dashboard. So that dashboard was created for a support of a assignment that I have given to ARMT students during their third year field training program. So I think now all of you are aware about that this Govinana mobile app. So where we included most of the POPs, package of practices, for around 60 crops. But actually that those are the step-by-step practices that farmers need to do during their cultivation. But I think all of you know that in the crop production is not such a simple thing. It's something compound. So it is not a copy and paste, right? So one practice that we do in one place cannot be applied as it is in another place. So because of that, we wanted to see whether all the package of practices that we have given in this Govinana app for crop cultivation are okay for farmers. So we use that app for with our students during their third year field training program. So I asked students to follow the guidelines given in the app, and then also I asked them to use the community module and give their questions to the farmers and take their answers. And also I asked them to use the helpful information in the module. So after that, at the end of the semester, I asked them to write an essay. So then they can highlight what are the information was used from using this app, and also that how we can develop these step-by-step processes of crop cultivation in the app, right? And also I asked them to give some suggestions for their for the improvement of this app. So that was the assignment that I gave them. So actually here we present this because that this is a kind of an example that we can use this kind of digital tools for our teaching purposes, right? So all of you are aware that generally in the conventional practice of doing the third year field training program is that we give all the package of practices on paper base to the students, or we explain those things in the lecture halls. Okay, but if we can use this type of digital tool, so then we can we actually can save some time, and also we can give the full package through it. So that was the idea. And also that there are a lot of benefits of this kind of activities. You know that this one thing that we can direct students to apply the theoretical knowledge that they learn for the real world situations. And also these apps provide many other information like weather data and also marketing informations, like several of informations that we can get. So then the students can use this information for decision making. So those kind of activities are helpful for for students. And also another thing is that we all know that our extension service has many problems. But if we can digitalize this extension via these type of digital tools, so then we can do it very efficiently and accurately. Like that, many importance in this type of activities. So, Lahiru will present once I give that assignment, so finally the question was that how students use this app, right? So, there is no way that assess how many crops they have added, how many times they use this app, and what are the activities they did through this app, like those kind of things. So to see those activities, Lahiru developed this dashboard. So he will present it.
And also I have to introduce Lahiru is a computer science student working with Prof. Indika, and for his internship he decided this. So you can see how faculty collaborations can be used and it be used. Lahiru, over to you. You can explain.
This developed for agriculture department students. We can check their performance in Governana app using. We can check it using their index number or phone number. This example, we can search here their index number, and we can see register phone number and index number, and they added crops in Governance app. They do activities in these added crops, and this area shows total time in app, spending time in app. Community time means community model. They spending in get knowledge from post and post sharing and react in community model area. This like social media. It's like Facebook, WhatsApp group. This student ranking number we related to their total time spending time, and using total time we get from register student 19 students in agriculture faculty. This leaderboard we can using total time or filter it at community time. We can get the idea about they are using app using time, highest filter and highest or lowest. registered 19 students. We can get idea about all of students' app usage, and these graphs and related chart shows their own selected student spending time, and average time this get by summation of all students spend time divided by all students, this average time, and we can get idea about average student spend time and selected student spend time. It's index, we search index number, and this is the highest spending time in performance of the their app usage.
Thank you, Lahiru. I think you get an idea where you all can give an assignment maybe with agriculture and then work with computer science people. We have a platform which is open for this university where they can develop, we guide them, and that's where you can think and see how you can assess what is the outcome, etc., than using the traditional methods of assessment. Thank you, Lahiru. Thank you very much. Yes. Yeah, here. I'm saying, look, you're now, I have shown you how to do it. Now take the lead and make a change.
Yes, this is not the complete system. This is the prototype. We need some comments to improve that one. How we can customize and what are things we need to add. Any suggestions and comments? Yeah. That is a problem. Yeah. Yes. Yes. Here we calculate the total spend time, but the problem is whether they have actively engaged with the content of the governance application. For that purpose, now we are analyzing what are the things they have done through the community model. Whether they have commented on the post, whether they have shared with the others, and they can answer the question asked by the farmers, like that. We want to analyze what are the things they have done, because it's another requirement from the Professor Deepthi. We need to analyze what are the things they have done, not only the total time spent on the applications. Okay? Yeah. Yes, now we are doing that one. Any other comment or the suggestion? Yes, sometimes, yes, this is a group project. They have allocated 4 crops for the group, but not only these 4 crops, they can get some ideas or get knowledge about the other crops as well. And also the pest and disease module available. There are many information related to the diseases and the pest and how to do the treatment, and likewise they can get information and knowledge. Not only the assigned 4 crops, there are many they can explore, and we can analyze what are the things they have, what are the things they have done in this through this application. Yes, we can customize this one. Not only this assignment, if you have any this type of application, we can customize. Yes.
To trigger the thinking and to show the potential.
Okay. Thank you.
Yeah. While I have this, let me also show you a few more things in our back end, just for you to get a feel. If I go to usage data and maps, this is the real-time map I mentioned. It might take maybe a minute or 2, but now it's computing where the farmers are and what they are growing in real time. And this is the information which can make a big change. Let's see how fast it comes. It also depends on the internet speed. But this ability is one of the major game changers. And here it is. And you can see there's a very high concentration down here because we have been working with the university and the Department of Agriculture. But every farm, what they grow, where they, how many farms in that dot because of the thing. We started here. It went into this area. It's diffusing, spreading into the middle and also to the north. And gradually, if there's value, this is spreading. And this is real-time map, which I know today, government and the consultants are being paid millions when we have it already ready to use. Then if I go to crop management and look at the dashboard, these are the crops which I mentioned, which is digitized. Behind this, that's the POPs, package of practices, all digitized, verified by the teams here. And that is what comes through the app for farmers to act, but these get translated. And initially we did a lot of manual translation, but the AI tools are now almost ready. We have developed it, and there's a research project happening in UOR where they are fine-tuning this whole translation process for Sinhala, Tamil, English, but very soon we need it in Telugu, going into India. And if you look at the crop care management, we said in the app there's a crop care module, but in the back end, for brinjals, these are the pest diseases. And if you go into any of these, you can see that information in English, Tamil, Sinhala. And so based on the condition, we can give that to the farmers and it talks about prevention methods, chemical controls, mechanical controls, biological controls. It has evolved into a huge system over time, which is available for students to use, participate, collaborate, and take it to the farmers and also to school children and others in Sri Lanka. So this is a glimpse of the back end. Before I close this, any questions you would like to ask? No, it's only the people who are using the app. So what we'll need to do is, if the government and all that come together and start, because through this you know exactly when the farmer grew something, and if you are going to think of insurance, you have a history. This person has grown from this. This is what happened. We also have the weather information. Okay, there was a disaster. Therefore, it's a very reason. This is where now what we are saying is we have the technology platform. If this is embraced by other stakeholders, we have done the technology, we are technical people. But if the other communities embrace, we can change this country. Question is, can we do that? It is, the block is here, not in technology. Yeah. Yeah. And we have statistically significant sample of farms. We know the location. Then we can predict for the population. We don't need the exact. If we get it around 10% accuracy, that's a huge progress from what we have. Yeah. 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 And then once we for the satellite images, we can check through the cultivation and do the triangulation. Because this data will never be accurate, but it is within 10% to minimize the supply and issues. So is the other half which is missing. And if I show one more thing before I invite Venkat to share his vision for it. So we said that there is a community module in the app. Whatever they use, all that messages come here. If they upload image, the images come, whatever they share. Now, Mahagoda Kanituduhala, they are another school, and Nape Gevatta. So you can see the engagement from all types of people. And this is what really gives me the energy to keep doing this when I see this type of development. And behind this, we are doing a lot of AI processing just to see the patterns where it is happening, and this is where the AI getting used in a very big way. It's another school. You can see the Stramadana, and that is where you can have competitions, what happens. There are questions about the issues, or someone is sharing sharing the harvest. And this is real, it's happening. And we see it in real time now. So I'll finish that and log out. And I'll invite Venkat. He's a PhD student, but tell a bit about your background, why you are doing a PhD with all that, and how he's used not only in agriculture. He started taking the bank to the village and building of that. So let me take this out. Sorry. Is that okay, or the pointer?
What's the time now? Good morning. So respected teachers, support staff from University of Ruhuna, my dear colleagues from Vidya, members from NSF, and my dear students, good morning everyone. My name is Venkat. I am from Visakhapatnam, a southern city from Andhra Pradesh, India. My first visit to India, and there is a lot of semblance between South India and Sri Lanka. Not much difference in the culture, the transportation. Okay, so I'm very happy to be here. See, I'm basically an entrepreneur. I manage 5 companies back in India across multiple sectors. So my first venture is a fintech company, financial technology company. The second company is an insurance company. The third company is into food processing. And the fourth company, which I started this year in January, is into manufacturing of agriculture spray drones. So I manage 4 companies back in India. And then I'm also doing PhD under Athula sir. So I joined this year in July in Western Sydney University. See, before I go ahead, I want to play a small video, and I request the students to be more interactive.
నిర్ధారణ కొరకు సెన్సార్ పైన ఉంచండి.
విజయవంతమైనది.
So you saw this video, right? So students, what is your view? What is happening over here? Can anyone say what is happening? What you saw in the video? Okay, so I'll give you a background. See, India is the most populous country in the world, right? 1.46 billion people reside in India. So out of 1.46 billion people, 1 billion people reside in 640,000 villages. Okay? Now, is it possible for a bank to open a branch in every village? Is it financially viable? Can Kargil or Keels open a branch in every village of Sri Lanka? Is it financially viable, sustainable? No, right? So this is where my company intervenes. So we basically act as an interface between bank branch and the village. Okay. So the person whom you have seen, the old person, he is my agent, banking agent. And we provide the banking agent with a device, okay, and a software. The device will comprise of a biometric scanner, a smart card reader, and a printer, okay. Now there is no need for people to go to the bank branch which is 20 kilometers, 30 kilometers away. Sitting there, within the village, they can approach my agent, they can open account, they can deposit money, they can withdraw money, they can apply for loans, they can purchase insurance products, okay, and they can even purchase mutual funds. So most of my customers are farmers and the pensioners, okay. So in the last 10 years, this is my first venture, a fintech company. So basically, our software talks to the bank software real time. Okay. So whenever transaction happens, immediately you will get a pop-up in your mobile phone, and the agent will give you a receipt. Okay. So in the last 10 years, we opened around 17 million zero balance accounts in the last 10 years. Okay. See, this is basically the device which we provide to the. So here you will, this is the screen. Okay. You basically have to give your thumb over here. You can withdraw money using your thumb, or you can even use the swipe the debit card. Okay. So we opened more than 17 million zero balance accounts. We have disbursed more than 5 billion Indian rupees worth of loans to farmers. Okay. And we have more than 5,000 agents across India. Okay. We have agents in Tamil Nadu too, especially Kanyakumari, Ramanathapuram, all they are in proximity to Sri Lanka. See, this is a report of one of our partner banks for the month of November. See how many agents? 772 agents. We call them bank mitras, okay? Because they are providing banking services in the villages, right? So we have 772 bank mitras, and for every 30 to 40 bank mitras, we have an area manager. Okay? So for the month of November, you can see these agents, they performed 534,000 transactions in 1 month. Okay. So total transactions is 534,000, right? The total business is how much? 5.5 billion Indian rupees. Okay. Now people are not going to the bank branch, which is 20-30 kilometers away. They're transacting with my agent. So we have a very seamless cash management system. Okay. So every month we do on an average 2 to 3 million transactions. And the total turnover would be around 30 to 35 billion Indian rupees. Probably 100 billion Sri Lankan rupees. Okay. So this is the business which happens through our platform every month back in India. And based on the throughput, the turnover, bank pays us the commission. So we earn on an average 40 million Indian rupees as from our partner banks. Okay. And 70% of it we pay as commission to the agents. The rest 30% will be with us to take care of our operational expenses. Now, see, because of this initiative, okay, basically a digital intervention, right? Because of this initiative, people started saving with banks, right? So this initiative led to tremendous increase in the savings, okay? And this obviously brought down the interest rates which bank charge, okay? So this is one initiative which we are doing successfully for the past 10 years. And I requested Athula sir to explore the possibility of starting a similar initiative in Sri Lanka also. Now, I'll come to the agriculture. See, India has out of every 4 farmers in the world, 1 farmer is from India, okay? India has the second largest arable land after USA. Now, like Sri Lanka, even in India, the land holding size and the average farmer income is very low in comparison to the farmers in the developed nations, okay? So now farmers, can they afford to purchase a tractor, harvester or a drone in countries like India and Sri Lanka? It's very difficult. They won't purchase. They would prefer rental services, right? Now, the other problem, the major issue which Indian agriculture is grappling with is the losses. See, there is a huge labor scarcity and outdated spraying methods. They are actually devastating Indian farms. Okay, so farmers even today use outdated, the manual spraying. Okay, which is very, ineffective. So because of that, every year India is losing crop worth $6 billion. Okay, to pests and diseases. Okay, and millions of farmers in India, they are suffering from respiratory diseases, skin diseases, vision-related issues, and many are even because of high levels of exposure to the agrochemicals. And due to that, there is a huge labor shortage. In India, if you want to administer agrochemical in your land, you won't get labor. So there is acute shortage of labor willing to offer manual spraying services. Because of that, the wages doubled in the here we actually want to bring in drone spraying as a transformative solution. Okay. Now with drone, to administer agrochemical in 1 acre land, it takes 5 minutes. Okay. It takes only 5 minutes. Whereas if you use the traditional sprayers, it takes 4 to 5 hours. Okay. Whereas drones can do the same job in 5 minutes. Okay. Now the second thing is, in 1 acre land, you basically dilute a chemical with almost 150 liters of water. Okay. So you're contaminating the groundwater. But whereas with the drone, we'll dilute the chemical with only 8 to 10 liters of water. Okay. So you're saving almost 90% water. Also the agrochemical, when you use drone, you tend to use 30% less agrochemical than the manual method. Okay. Most importantly, the drone spraying, don't think it is very costly. No. Drone spraying is more cost effective. Is cost effective vis-a-vis traditional spraying. To administer agrochemical in 1 acre land, we charge only 500 rupees. Whereas traditionally, the price is between 500 to almost 1000. Okay. So we felt that there is a huge demand for a drone, okay, which can administer agrochemical. So this company I started this year in January, Super B Aeronautics Private Limited. Okay, so here we basically manufacture agriculture spray drones. Okay, we got 7 design patents. It's completely 100% indigenous drone, designed and developed in India. So this is the drone. The total weight of the drone is 27 kgs, and it has a 10-liter tank. Okay, so you fill agrochemical, water, and then you can spray. Okay, so with single charge, you can spray, you can cover 4 acres. Now, the crux is taking this solution to farmers. As I said, farmers won't be able to afford drones because each drone will cost you somewhere between 500,000 rupees to almost 1 million Indian rupees. Okay, it's very costly, right? So we basically want to Uberize drones, right? So Uber basically what they have done, they have connected farmers with the drivers or the pick me. Okay. Similarly, we have millions of farmers who need the service. We have drone entrepreneurs who wants to offer spraying service. Then there has to be a match to be made. Okay. So we are, as a part of my PhD, okay, under Athula sir, I am developing a digital drone ecosystem, okay, which will connect farmers with drone service providers. Okay. So farmers can request for spraying services online, okay, and the farmer will get the service through the nearby DSP, okay. Yeah, so that's about it. I always felt that farming is a thankless job, right? Okay, so it is our responsibility to do research, time research, which will benefit farmers. Okay, so I hope I am moving in a right direction under Athula sir. So thank you very much for the opportunity.
Thank you, Venkat, for coming all the way from India to share that experience, because it gives a sense of this problem magnitude and what can be done. And it actually gets you to really think what the problems you need to solve. Because it's not easy to connect it's my drone, which they have done, all engineering, but when it's trying to embed in the society, usable form, that's where the socio-technical system theories come into play. And how do you build the trust, the value, coordination, and some of the other issues is, okay, if you only get 1 acre or 2 acres, it's not economical for the person to take the drone there. But if we can coordinate through a system where if we know the harvesting, the growing patterns, we know when the drone spraying is required. In that window, there's a special discount. You book the drone service. So we aggregate. The moment you aggregate, it becomes economical. Right? So those are the thinking we need to do and create the systems, validate it with people, and this can revolutionize. The next thing he's looking at is putting a multispectral camera into the drone. So when it's flying, you detect where it is required, where it is not required. Yeah, but
stress among plants.
So it's not just sort of the IoTs or the digital. Moment you start to think at the systems level and start applying, we can do wonders. And I'm just giving a taste of things that can be done if we think outside the box. So with that, I think we are finishing at 12:30, is that right? Yes. So I think the key thing is now you all have heard the various possibilities. So let's see what you think, because we have been talking and I like to know your ideas. So we are going to ask a question. This is some bit of the group activities. I thought I'll do it this way rather than moving out. Please get your smartphones. Can we remove that message? Scan this QR code. Then you will find there is a question. Has everyone got the application? So I want you to think from listening to all this, suggest possible applications you would like to develop using this technology. So based on what you heard, what do you application that you want to put your time and effort? So you can say, we can do multiple, right? Okay, you want to go back? Sorry. Yeah. Seven. So it's time for you to think and see, come up with some ideas based on the problems you all have encountered, observed, you think worth solving, and type your ideas to see, which we can sort of discuss further in the next session. keep typing in. We have got 26 responses from 71 people. We need a bit more. Ooh. Okay, 31 responses. Please be active, participate. 33, 35. Okay. Progressing 41. 44. These are the individual responses. Can we do a regrouping? Because this is the AI version. We are using the non-AI version the first time. But again, this gives a flavor of in the digital world. Earlier, I was debating whether to go out, have groups, and think about it. But looking at the situation, I thought let's try the digital version. So behind the scene, I think they must have done some AI. But the thing is, again, look at what you have written. I think this is a key point. And ask, with those suggestions, who will benefit and why we want to do it. Because we tend to do a lot of things, but what is the impact? Out of those, which of those changes can make a big impact? Because you all have got a feel for the magnitude of the problem we have to solve. Instead of thinking of small things, as a system, how can we make a difference? I think those are the mindset that has to evolve. And why I wanted Venkat to make that presentation is, it's not the academic research we used to know, especially when you all are now discussing about curriculum thing. He's an entrepreneur, he has a problem. Yes, he has the necessary research background. Right? And there's a missing knowledge in order for him to solve that problem. When we analyzed, there is enough depth, so why not do a PhD? Yes.
Actually, there's a grant scheme, the National Science Foundation, which facilitates the new entrepreneurs to develop technologies to the market. Technology Tech D grant scheme and startup grant scheme. So I see a big potential linkages of what we discuss here and to take them to the market. Maybe initiated as a research by the Faculty of Agriculture with some grassroots community and maybe entrepreneurs, maybe industry at a village level, maybe with the linkage of Professor Ginige, or maybe various potentials might be there, and maybe with the funding applications to NSF. So there may be ecosystems which could evolve.
Thank you. I think if you all have been thinking of doing a job, I ask you to think twice. In another 2 to 3 years' time, will that job exist? Right? If you are thinking of a job, please ask that question. It is for your own benefit, especially I'm addressing the students. Will that job that you are being trained will exist? But what we know is there is something that will exist and we need more. There are problems. That those problems needs to be solved. And that solution comes through the entrepreneurships. If few of you all can get together and start looking at a problem, there is funding because that's the new, you don't go to a job, you create the jobs. That's the new future. Right? So please take this seriously, especially if the students. Most of the jobs, the way we know, will not exist within the next 2 to 3 years. And in the afternoon session, I will show how globally the jobs are crashing left, right, and center. I have the statistics. Right? So this is a very critical time where a lot can be done, a lot of problems to be solved. But unless you think differently, you will find you will be idling after your degrees. So, and I'm glad that this type of thinking is coming in to start that different way of thinking, and it has to, again, it's not individual. These problems are very big. If there is a way of coordinating different people working on different paths, we can solve it. Now, if I look at these systems we have, certainly in the village, farmers' collection centers, packaging, how we can bring in sustainable packaging, quality assurance. There are critical problems that has to be solved, and it needs the scientific knowledge you all have gained about the product, the quality, various certifications. But it is not knowing the certification, but how you apply the certification to solve a problem and be part of the economic system. I think that is the change which is a must. And if last minute thoughts, I think we are breaking for lunch in about the 2 minutes time. Any thoughts, comments? Yeah. The AI is the chatbot. These are the where AI is going to make a real change, where you put your ideas, you immediately group, you connect them, you facilitate that, best out of it. And I'm just sort of giving a bit of flavor of what's possible. And in the AI session, Ruhuna will also present some of the way she is doing research now, just to understand what the research journey is in the new world. I think with that, we'll break for lunch.
A truly integrative and impactful session. Thank you once again, Professor Athula Ginige, and all the dignitaries who have led the discussion. And with that, now we will break for the lunch until 1:30. Please enjoy your meal and reconvene on time to continue our rest of the engaging sessions. Thank you. A warm welcome back. Our exploration continues with one of the most transformative topics in agriculture. Session number 3, Artificial Intelligence in Agriculture. Professor Ginige, the stage is once again yours.
Hello, can you hear me? Yes. Okay, so we'll come to the AI part. The world is changing. This session, probably I'm going to do a blend of questions as we progress. And sometimes I might just tell you the question if you can put it onto me. We can, because it's very important to your participation. So how the AI revolution, what is it? The first part will try to understand the AI. Then I will ask one of my PhD students who is here, Ruhuna, to demonstrate as a researcher how she is using AI in her research. Then after that, we can discuss what does it all mean going into the future. The big question is, can we keep doing what we have been doing? So with that, we are entering a new era. The technology that can write articles, generate code, create these pictures, art, text prompt, they are no longer scientific fiction. It is rapidly reshaping our professional and economic landscape to ask some very serious question. The one I asked earlier, what is the job you are going to do? Will AI take it over? Or are you going to tame the AI and make it your friend? So what it can do, especially in the last maybe 1 year, 1.5 years, is amazing. When it first came, it gave all sorts of wrong answers. It suggested papers that did not exist. But now look at it. If you do a literature review in Gemini, which we normally would have spent good as a researcher, 3, 4, 5 months, I now do it in half a day, about 3 hours. And all the literature, all that is right, but only thing is, I had to give the right prompt. Because basically in AI, garbage in, garbage out. So you need to know what to put in to get what you want. So let's understand this. What is your understanding? Okay, let me ask a different question. As powerful as a human brain? Will it now, when we think of a problem, we have something called understanding. We say, now I understand. Will AI ever be able to understand the way we understand? Will they be able to sort of replace us completely? Have you all watched this movie called Matrix? Yes? If you have watched it, that's one fiction, where humans just power the whole matrix and it creates this artificial world. But if you look at it, the broad field of system built by people that can analyze large assets. Because basically what happened in the early days is we were able to use various algorithms, again computations, as I mentioned, and classified patterns. Now, handwritten character recognition, which is in your phone, every one of you all will write the letter A in very different ways, but it will recognize it as A because all that been analyzed and it can do pattern recognition. So when we digitize large amount of information in Wikipedias and all the books, they analyze those patterns and there were particular patterns about patterns. Now, what happens is, so that's the basic artificial intelligence. It was able to classify the patterns. This is A, this is B, this is a fruit fly, this is aphids on a tree. It was classifying. But when you have the patterns, generative AIs, when you give a prompt, it can, using the pattern, now generate new information. Earlier, generating any new information, just classifying. Now, with generative AI, it used the prompt and the stored pattern. So its memory has got the patterns. And it generates a new set of text, new set of images, new set of videos. It's all generated by AI. For example, this presentation is AI generated. I didn't do it. This is AI generated presentation I'm using, but I knew what to tell it to get this done. And then those patterns, they are called large language models, and they become available for us to use. So large language models, so LLMs, are pre-trained patterns. On top of that, given a prompt, we can generate patterns. So ChatGPT, Gemini, all those are large language models which has been trained on trillions of data patterns, and we can give a prompt and it can generate new information based on the input. So let me explain that a little bit more. It's prediction, not comprehension. That's why it's different from human. It predicts words. So, for example, the farmer loaded the harvest onto and then it will look at, based on what was said before, what is the most probable next word. Is it the shelf, cart, truck, trace, and that probability is all based on probabilities. That probability is based on what was said before, and it predicts the next word. So we think how it can do it, but what we know is from the results, as you said, it can surpass even the speed at which it generates and predicts, and it's correct. So it's a probabilistic model. And again, of scientific knowledge, the old way, a bottleneck in memory, because earlier, before the current wave of AI, there was a recurrent neural networks which was trying to predict one word at a time. Okay, this was what. And a very interesting paper came up in 2017 where self-attention mechanism was allowed, where the prediction started to happen in parallel.
So the farmer parked the tractor in the barn because then it looked at all these words, the probabilities, and because tractor, it knows, okay, I can refer to it as it was full, and it will predict that word. But it happens across multiple layers speed. So AI is where it can predict based on your inputs what is the next word, next word, next word. And also based on memory. Prompting becomes very important. And then they were talking about prompt engineering, how you design the prompts. That has become a new interest area. Again, I don't know how long it will go down that way, because we are already talking about agentic AI, the next wave. Now the thing is, it's happening. There are these big models, DeepSeek, ChatGPT, Gemini, many others are coming. But for us, as I said, the building blocks, how do we convert this into an economic impact? That's what matters. Again, it won't be possible for us to put that much of time and effort to create the language models. We can do some research, we can learn something, it's useful to know, but the real impact is how we can make use of these language models. And basically, it can automation at scale. When you have large data sets, it can decide when to irrigate, when to apply fertilizer, all that can be trained and decide very fast. It can do the analysis. I think when we have large data sets, we just feed it and it will give some very interesting insights. That's very fast. And also it's available all the time compared to humans. Sometimes I'll put a prompt and before I go to sleep, and in the morning I have my report. So we need to look at AI as a new co-worker to work with this new era. So here are some examples. Bank of America, Erica, was managed over 1 billion customer transactions, offering financial tips and processing transactions. It has been used in legal compliance. Extensive AI. So software coding, that all happens. So if you are looking at programming, it's a very interesting question. Programming jobs will remain going into the future, especially when you are in a stage of redesigning the curriculum. All these are factors that one has to take into account. Then another area is content creation. Its presentation itself is an example. But it took a while to get the right script, the message, and then it did the rest for me. Any questions? That's just a quick overview of AI without going too deep into technicalities. Any questions before we look at how it is transforming the world's oldest industry? Just take a pause, because you all are very quiet. If I was doing it in Australia or something, I would have got many more questions by now. You all were told to get maximum from me, so otherwise I think I should ask questions. Anything you like to ask at this point before we go, because I did a quick overview of AI rather than going into all the deep mathematics behind it. No? Yeah.
So in a complex situation, how can we trust that these models will be really up with our targets?
Yeah, I think the key is we'll have to do lots of testing. And that testing, for example, I'll give a more concrete example from our apps. Now, we are using AI to generate content. I'll demonstrate all the pest and disease information is now generated through AI. And I can show you the process. But we don't trust. We extract that into spreadsheets. The spreadsheets are given back to the people. Then they look at it, they say this is right, this is wrong. No, you can't use this pesticide because it's been banned. So those are the practical situations. So we mark all that. And then they say, look, yes, these are missing. So there are missing bits that they get added. But the difference is, if we said, look, give us a sheet or this information, done, it will take so much time for them to do it. But when we give the sheet, it's much faster for us to correct than to create. I think that's the basic principle. In many things, when we are marking, etc., we can correct it. So that is where you need to understand what the AI, what it can do, what's its limitation, and convert that into an economic impact, which is we can now reduce the time to add a new pest or disease into the system considerably. We come to that. But having said that, when it goes to the, now it's very, but still it can, so when it goes to the, we get the feedback from the community module. If there is an issue, a question comes, there are multiple feedback loops to validate this is correct. So if it has been stable for a while, there's nothing exact, the confidence level goes up. So after it reaches, we put it out. I am not sure whether it's that trial and error, because there is a logic, there is science behind it. It's not arbitrary. For example, look at the atomic when it's called a plum pudding. It's like a pudding with this with the electrons and the protons. Came the atomic structure and they said that thing that cannot be broken. Right? Then it was challenged and it became mesons and protons and neutrons. Atom can be broken. Then it became, no, it's not even solid. It can be a wave or a particle. So understanding, we only, like, correct for text, we keep using it with the knowledge that yes, new scientific discoveries can challenge it. So even with many things, I think with this type of work with AI, what I see is continuous knowledge creation loops are becoming more and more important. If you can remember the research group presented, Samya, Dimitri, like looking at that whole knowledge creation loops that is happening in the farming community. And she has identified the things that was in that video. This is where we have to look at what AI can do and make use of it with the necessary guardrails. Any other questions? I think before that, I think the previous one. So here, now imagine that the drone is going to spray, and there's the multispectral camera, and in real time, though the picture is like that for the human eye, on the multispectral you see particular signs which indicates particular issues. And you adjust the spraying, or you just do it where it is necessary. Now, all that processing can be done by properly trained AI models. Then smart farm automation in the field, see and spray technology. This system uses AI to distinguish weeds from crops in real time, applying herbicides only to the weeds. So that mass spraying can now be pretty much targeted with the equipment AI powered. Then major area is this chatbots. We are the agronomist in the pocket. We are at the moment in the apps also you have to press etc. But with the chatbot, either you give a prompt or you ask a question, iteratively it will refine it. Now you can upload a picture today to Gemini and it comes up with pretty good responses. But the question is again the trust, how much we can trust. We don't know where the information is coming from. So in our work, as I mentioned earlier in my slide, we create our own knowledge pipelines. We put curated information, and then from that, the knowledge graph, we extract the information so we know what went in is right. Therefore, when the users ask, they get that curated information. So knowing what can be done, what we are doing is, for advisories, etc., we build our own knowledge pipelines. So that work is right now happening within the back end of our system. And again, another key point is just you need to understand these limits. It's not always right. And the guardrails are extremely important because it's probabilistic. Moment if the prompt is not correct, it can go at a tangent and producing something very different. And lack of reasoning, inability to grasp cause and effect or recognize subtle emotional cues. So certainly for high-stake fields, human verification of AI output is not negotiable. So those are some of the things to remember in using AI. So if you want to ground the AI in reality, instead of searching the knowledge base, there is a new technology that has come, RAG, which is retrieval augmented generation, where you have the prompt, you also load your own documents. And the question, then it is very good at analyzing it and giving the answer based on that. How many of you using the notebook LM? One, two. Do you all know about notebook LM, a tool, a free tool? Available, yes, no? I'd like to get some responses. Okay, please put up your hand if you're using notebook LM. Okay, 1, 2, 3, 4, 5. Okay, so it's important because if you are using, I don't have to tell about it. If you are not using it, it's a very, very versatile tool. So majority of you all don't know about notebook LM. Because these slides, all that you can see, I use that tool to generate. Are you going to cover notebook LM a bit, or do you want? Yeah? Okay. I'll leave that to Ruhuna then. But here you ask a query, retrieve the system. The system first retrieves the relevant facts from the trusted, up-to-date knowledge base. So this is where we limit where it search space. And generate the LLM, generates the response. So we have the basic AI, which goes to the global knowledge. And the next version is you use your documents to generate responses. For example, I also teach a subject called social computing and systems thinking for the final year undergraduates. I've done away with textbooks. We give them the papers where the discussion, again, no lectures, more discussions. The way the discussions are done, they need to put those papers into notebook LM. Then they can ask questions. And they can say, explain it to a 10-year-old, explain it to a 15-year-old, and the concepts it will explain. So now that capability is available in this tool to explain, to show some of that. But the bottom line is a smarter, fast, and
Recording
more
in
effective
progress.
approaches. No? Okay then.
Good afternoon, everyone. I'm Rifana. So I think it's not a good time to talk after a heavy meal. It was nice, thank you. Yeah, I was put in a spot to do this one. I was a bit reluctant as well because I don't want to show what I'm using in front of my supervisor. But anyway, I'll discuss few of the tools I'm using for my research. Maybe there are people, they already know what I'm using. But when he was asking who is using Notebook LM, I saw few responses. But it's really great tool you can use. I'll show you something what I'm doing, okay? So before goes to the presentation, yeah, I would like to tell about me. I'm one of you. I'm an agriculture graduate from University of Peradeniya. Then I did my master's in economics from University of Colombo. And now I'm doing PhD in Western Sydney University under guidance of Professor Athula Ginige. Actually, I'm doing my PhD in School of Computer, Data and Mathematical Sciences. And many people, when I'm meeting there, they're asking what you are doing in your PhD. So when I'm telling about this, like in data and mathematical science and the computing, they think I'm an IT person. They always say, wow. I said, no, don't judge me. I'm coming from a different background, agriculture, economics, and now I'm getting flavor of IT. I'm trying to code. I try to learn everything. So, bit of my research. So, I'm today not going to talk much about my research. He already told about these, the value creations, the value capture, and the distributions. That's from my research. But before going into the AI tools, I'll tell about a little bit of my research. So I know you are coming from agriculture background, and I was working in agriculture sector as a researcher for more than 7 years. So I was with farmers, and I saw they are not using mobile applications or any other tools. But if we go to the literature, or if you talk to the expertise or anybody, they know the reasons. They know the causes. They might say, we don't have data, we don't have the tools, we don't have money, we don't have so many things. Those are the causes. That's already explored. But in my research, I'm looking at how we can create value for them. By creating value, how we can make adapting these digital technologies. So that is what my research is. So that is something interesting, because I'm looking from the angle of systems thinking and the design thinking. I'm not going to explain anything here. Quickly moving into the next slide. Okay. So this is one of the tasks I usually do with my supervisor. So this is the brainstorming sessions. So this is the whiteboard. So we used to have brainstorming sessions, and we try to write and brain dump whatever we think. So this is the manual part, but this is the AI generated. So we take a picture, we upload that one into Gemini or ChatGPT and get the summary and like getting analyzed. So it is not creating from its own. So it's creating from whatever we are doing. So this is one of the tricks I'm doing. And the other one is the Google Notebook LM. So earlier you have seen a video, right? The Digital Agriculture Research Group from Western Sydney University. That video is entirely created from Notebook LM. So what we have done was, we are around 6 PhD candidates. So we have created a page of what we are doing. So then we uploaded that one. Iteratively, we created few videos, and finally we have satisfied with one. So that is how that one is created. And all that images and everything, those are from AI. So actually, if you can now even try, you can go to the Google Notebook LM if you want to try, because you may forget it once you go home. Do you want? Just check. And it's free for you if you have a Gmail, because it has many things you can do. You can get an audio, like podcast. So what we are doing is, when there is like even I'm doing with the YouTube videos, if it is like 2 hours or 3 hours, even if it is like 2 lengthy papers, we upload it and we get the podcast. So that's like 7, we can make it based on the time requirements. So we can listen when we are free. So that is the podcast. The earlier we have shown you the video cast or video overview, and there are several tools we can try. And the professor has used the slide deck to create his presentation. And the infographic, there are beta versions, and everything free. So I think this is one of the very best tool for you if you are undergraduates or like, yeah, you are doing your studies, because it's free and it is not extracting from anywhere. Like whatever you are feeding to this, the documents, you can upload many more, like, I don't know like the numbers, but you can upload many in a different format, like the text, PDF, documents. Then you can have a chat. I'm showing a different slide. Escape. come and go. So I need, can you sit here? Okay.
Second is the screen.
Okay, so I have to look from there. Yeah. Okay. So this is the notebook LM. So if you have a Gmail account, you can open it, and it is free. So I just want to show you like what you can do. So you can go, and there are so many features you can play around here, and you can create a new notebook. It's a quick demo. Yeah, you can upload whatever the documents you wanted. You can do a quick literature review or create your presentation. You can make quizzes, the flashcards. So when you created it, you can give the options here, like whether you want to create a video, podcast, or slide deck. Yeah. So, for example, zero sources. Yeah, this is one of the project. This is our research. So we have uploaded our research to the notebook LM. Then we have created the video cast, and you can see even this is very handy and it's very nice. Sometimes we spend hours and hours. So this is actually like every year end we have to present what we are doing to the whole entire school. So we didn't have time, but AI helped us, and we even won this competition. So that is one of the tools I want to show you. There are so many features. You can play around and see. I want to go back. Now I want to go to the presentation. Presentation, yeah. Yes. Other one I intensively using is the Google AI Studio. Anybody using it here? No? So this is even a free tool. You can go here and you can create your own app with prompt. So what you can do is, like, because it has in the AI Studio, there are so many features. I'm utilizing this for my questionnaire preparation and so many things. So even because I want to communicate with the people who are from IT, so maybe they need to understand what I'm telling, but it's very easy, like when I can prompt it and show them like what this is what I mean. So this is very handy tool. So you can prompt what kind of like things you are expecting. So I think you can remember because the professor was talking about the market readiness score. So this came as, because we had interviews with the farmers and the buyers. So we understood that there is a huge gap between those two parties. Farmers don't trust buyers and buyers not trusting the farmers. So because we know the prices are always fluctuating. So farmers usually showing the opportunistic behavior. So whenever they get the higher price, they try to sell it to those people. So to overcome those issues, now we are coming up with a market readiness score to keep them from logging to selling. So for that, so this is Google AI Studio created interfaces. So it shows based on app features, how we are going to give them marks. Actually, like this is interactive one. I can go back, right? Yeah, that's better. Yeah, I already. Yeah, this is the Google AI Studio. So what you can do is you can type here, like you can prompt it. You can ask what do you want here, like you want to add crops or like anything, any applications you want to create. So you can just need to prompt it here and it will create with even the code and API and everything. And you can visualize it as the mobile or tablet. So these are few examples. Like we have initially created to transfer our concepts to the development team. So this shows the leaderboard and how these example farmers are getting marks. And already our development team has implemented this part. So I can show a few of those dashboards. So from that to here. So now we have each farmers, how they are engaging with the app. So you can see these are the users from the app. So we have the dashboard with the monthly, weekly, daily user activities. And now you can see how they are interacting in each and every module. So this is deployed one. So that is from Google AI Studio. Any questions so far? Did you learn anything new? Those are really free. If you have time, just go and just play around. That's very handy. And you can make interactive presentations and, you know, you can utilize that to learn many things. And even the Google AI Studio has a text-to-speech feature. I'm utilizing that one as well because sometimes I need Tamil or Sinhala translation. So I can show you like what it has created. For example, no dear.
පිළිබඳ කෙටි සමීක්ෂණයට ඔබව සාදරයෙන් පිළිගන්නවා. අපි මේ ඇප් එකෙන් බලාපොරොත්තු වෙන්නේ ගොවිතැන් කටයුතු පහසු කරලා ඔබේ විනන ඇප් එක පිළිබඳ කෙටි සමීක්ෂණයට ඔබව සාදරයෙන් පිළිගන්නවා. අපි මේ ඇප් එකෙන් බලාපොරොත්තු වෙන්නේ ගොවිතැන් කටයුතු පහසු කරලා ඔබේ අස්වන්නට හොඳ මිලක් ලබා ගන්න උදව් කරන්නයි. ඇප් එක ඔබේ වගාවට ඕන කරන නිවැරදි උපදෙස් ලබා දෙනවා. වෙලාවට හරියටම කාලගුණ තොරතුරු දැනගන්න පුළුවන්. ගැටලු විසඳ ගන්න වෙනත් ගොවීන් එක්ක ප්‍රජාව හරහා සම්බන්ධ වෙන්නත් පුළුවන්. පලිබෝධ සහ රෝග ගැන මඟ පෙන්වීම ලැබෙනවා. වෙනත් ප්‍රයෝජනවත් උපදෙස් දැනගන්න පුළුවන්. ඒ වගේම පිළිකත් ගැනුම්කරුවන්ට ඔබේ අස්වැන්න විකුණන්න වෙළඳපොළ සම්බන්ධතාත් ඇති කරනවා. දැන් වැදගත් කොටස. අපිට පුළුවන් මේ සේවාවන් විවිධ මට්ටම් යටතේ ඔබට ලබා දෙන්න. ඒ නිසා අපි මේවා විවිධ පැකේජ් විකල්ප විදිහට සකස් කරලා තිනවා. උදාහරණයක් විදිහට එක් විකල්පයකින් ඔබේ ගොවි පොලේ විස්තර
I just want to show what it can create. So it's not created by human. So I gave text, it created the voice. Even, yeah.
வித்யா ருகுண கோவினன மொபைல் ஆப் தொடர்பான இந்த சிறிய ஆய்வுக்காக உங்களை அன்புடன் வரவேற்கிறோம். உங்கள் பயிர் செய்கை நடவடிக்கைகளை இலகுப்படுத்தி உங்கள் அறுவடைக்கு நல்ல விலை கிடைக்க உதவத்தான் இந்த செயலியை நாங்கள் வடிவமைக்கிறோம். இந்த செயலி மூலம் உங்கள் பயிர்களுக்கு தேவையான சரியான ஆலோசனைகளை நீங்கள் பெற முடியும். කෙටි සමීක්ෂණයට ඔබව සාදරයෙන් පිළිගන්නවා. විද්‍යා රුගුණ கோவினன மொபைல் ஆப் தொடர்பான இந்த சிறிய
I'm using and yeah, in my research very much. So for that I need to create some pictorial cards. So for that even I am using AI tools. So based on the AI icons. So I am offering like with the different levels of features we are showing. So all that I am not taking much time. So it's AI creating within seconds. And other than that, like few more examples I can tell, because I am using the digital versions of the questionnaire as well. I don't know whether you are familiar with the Kobo toolbox. That's one of the CAPI, like you can do the surveys. So that's even the free questionnaire tool. So for that, there are like, we can upload the XLS form. For that, maybe sometimes you may think you have to learn. I already know that, but sometimes I don't know. Then I have to go to their community and learn. But now, with the ChatGPT and Gemini, I don't want to. I just can quickly go there and fix the problem. And especially the translation part, I use Gemini. I trust Gemini because it can create the contextual translation and do the analysis. Even though I'm familiar with the SPSS, Tata, and all other things, sometimes when I feel I'm stuck and I have doubt, I directly go there and ask questions and clarify. And we can do the literature review with the Gemini, ChatGPT, we can do deep research. And again, when we are having the stakeholder meeting, we get the audios, so we get the transcript, and we do quick analysis. I'm using the notebook LM here, and the image generation. Yeah, that is few of the tools I'm using. If you have any questions, you can ask.
Thank you, Ruhuna. Any questions for Ruhuna? But it raises the interesting question, like when we talk about AI, it's not just putting it into IoTs, etc., because that's known, that's why we didn't go much into it. But in your day-to-day activities, as a researcher, you can see how it is changing the tasks you do, the complexity you can manage, and how the productivity is increasing. And that's why I asked, if you're thinking of a job, whether that job will exist. It will still exist, but a job where there was 5 people working, now one person will be able to do more than that. Therefore, 4 jobs are no longer available. Yeah. Yeah, so it's a very good question, because with this, especially in research, we saw the rise of articles that has no solid background. Now think of it this way. I can do an article, a research paper, on the work we are doing, and I can prompt AI to generate it. But it has to be backed up by the 12 years of actual research that has been done, which needs to be cross-referenced to the articles that has already been published. And also, there has to be data sets to show that this actually happens. So the question is, how it was written, is that the issue? Because if AI can generate the writing, so much the better. But have we done the work? Do we have evidence that it has been done where the peers can assess and say, yes, this is the work, but the whole paper is AI-driven? Then there's no issue, because we are sharing the actual knowledge. But if AI does something which does not exist, that's where the ethical boundaries are being crossed. Now, peer review has become a very interesting challenge for us because of that, and we have to cross-check. And again, that is very easy, because when I get a paper to review, I'll put it into one of these tools and ask it to find all other related papers, the background, and I can get the research journey of the researcher.
Now, if that journey is consistent, then we can see that the logic is right. Now, I can show many PhD theses. I just put it there, first get the quick analysis. And I can check the logic. I can get the mind map. And if it is not properly done, cracks appear. So again, when the way it's being written, the way of writing changes, the way of doing the peer review has also need to change. Otherwise, there's a mismatch. So there's a very big learning curve. And we need to, not only papers, what about the assignments? How many assignments in the universities are now AI written? Is it right? Is it wrong? What do you think? Yeah? Okay. If you get an assignment written by a student, or if you write an assignment as a student, are you doing the right thing or the wrong thing? What do you think? Any ideas? There's no right or wrong answer, but I like to understand. What do you think? Yes, it's okay to talk. Yeah. Anyone else wants to express an opinion? Yes. Sorry? Yeah, okay. Yeah.
Thank you. I have a question regarding the peer review process that you earlier referred to.
Yeah.
My question here is how ethical as a reviewer to first to upload it to the large language model and check it from the that's this kind of models just to understand the concepts behind it, and then when we upload it, so the model will also learn from this input that we are giving, and then how that will be affecting the transparency and the ethics behind the reviewing process.
Thank you for that. Because the very first thing is, it should not be publicly available. Right, in the sense, if you use it, it should be private. So this is where the notebook LM is quite good, because they guarantee what we upload will never be used to train their models.
So then the question is there a gateway that preventing the leaking of information from our internal information to the large language model training? So because these contents are not being published yet.
Yes.
And if it is to be used by some of the other reviewer who has been sent to reviewed like very confidentially, once it is breached, and that will be trained by the model, and then someone else will benefit it.
Yeah. So this is where you'll need to verify. You can look at, if you look at ChatGPT paid version, they give a guarantee this information will not be used to train other models. So it's private. That's why the companies are now using the commercial version of ChatGPT, because this is your own repository. Notebook LM gives that. So thank you. If we are doing it, we have to be aware of the ethical boundaries, and if that guarantee is not there, we should not use it for that type of work. So thank you for that, highlighting it. Any other questions? Okay, let me get my computer. So before I move on, let me show another practical example where we use this to generate pest and disease information. Internet. So when we want to add a new pest or a disease type information, what we do is we select the crop. We say cotton. We want to know about cotton. This is now the backend is all AI driven. And this searches the global knowledge base and say these are the insects for the cotton and the disease list. And this is where this needs to be driven by someone with local knowledge. And they can say, these are the ones where you want information about. You can select that and say, generate the report. And in the back end, it's all AI. It's processing. So it received the symptoms. Now it's looking for the prevention methods. Received prevention methods. Getting control methods. So it has got all that information, now looking for the causal agent. So we can create a systematic pipeline in code to work with the AI systems. And now it has got all that and is generating a report which we can download. As I said, we don't trust this, so we download it as an Excel file. Open. So this goes to the experts at this point. This gets verified. Then the things get added, all that. It comes back, it gets loaded. And then the corrected sheets, we also have another AI-driven tool. We give that tool, and then we get the Sinhala translation and the Tamil translations, because our base working language is English. They also get checked, then get uploaded. And that's the information you saw earlier in the pest and disease dashboard, which then comes to the farmers. If there are issues, we go back and change. So something that took months to finish now, a new pest or disease information, we do it within 3 to 4 days, depending on the availability of experts to verify. So basically what AI is doing is giving us a huge productivity boost by creating it and integrating with our processes. So the big question is, what does this all mean? Where does it going to take us? But before that, I was expecting to get more questions on this area. Yeah. 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 I mean, we can do that type of verification. Now here, if you look at this particular one, we selected the ones we want, and it will regenerate. But with this, again, we can rethink how the education is done. Because if the students can do the verification and then discuss as peer learning, and through that the academics can also guide, there can be new opportunities in that whole education process. So with that, let me take you to the last part of this discussion or the talk. What does this all mean? And where are we heading? Like, can we keep doing the same thing, preparing a new generation of problem solvers for the fourth wave of civilization? I think that's what excites me, and I'll show you what it means, the fourth wave. And for that, we need to go back in history, how the civilization has evolved. The first, it was the agricultural wave, and when we learned how to domesticate the crops, that wave started. And in the 1750s, we learned about steam power. We learned how to augment the muscle power of the human and the bull with the machine power, and that was the start of the Industrial Revolution. And the people in the villages came to the cities, the big cities came up, and whole social and economic structure started to change. Then in the late 50s, we learned how to code information as bits opposed to atoms. What you write in that book is you are coding information on atoms. So if you want to give it to someone, you have to carry it. If you want to replicate, you have to take it to a photocopier. But what we put it into a WhatsApp is coding the same information at bits, press a button, go to the other side, and you get the response. Very, very different properties. If you code information as atoms or bits, we learn that, and with that, the free trade started, the global world became smaller or got all connected. And now, we are going through another stage, and the basic clue to that is, here, the information networks was word of mouth. The families, the elders talking to the young. And based on that, that shapes the culture. What you do, how do you do, all that was shaped through that word of mouth over the centuries. And here, the information moved from word of mouth to printed books. And with that came the schools, the universities, and the structure started to change. And here, it became digital, and the Google search and the whole information flow changed, but it is digital, And that is when the pattern started to emerge. And now we have enough patterns to generate the information that wasn't there before. And that is where all this productivity boost coming. So there is, at every point when there's a change, there has been a major change in the way we create, process, and disseminate information. And that's happening. And when that happens, what we created for the third wave becomes obsolete. And we need to rethink what the fourth wave should be. From agrarian to industrial, a lot of change happened, social structure, education system. From here to here, again, fair bit of changes happened, the way we learn, online learning, all that came. Now, what is the fourth wave, and what is that? So as I said, the third wave was built on the premise that information is now coded as bits opposed to atoms. And we created these global systems, global connectivity, shipping networks, trade. And now what's happening? In the last few months, this has started to crumble, fall down. If you look at the job losses today, whether it's the IBMs, the Amazons, the TCS, they are reducing staff left, right, and center. Not only that, the banks, and just about 2 or 3 weeks before, the premier research organization in Australia is CSIRO, if you know. They announced 350 job cuts of scientists. It's not only IT. The 350 jobs are going within months in CSIRO. Why? Because we have so many problems to solve, and we need the scientists. We encourage STEM education, but the government is saying, no, we are not funding you. I showed this slide earlier. We are far from achieving the SDGs, but they are saying we are cutting funds. Why? These are some serious things, especially for young generation to think going forward, because what they are producing has not solved those problems. All the money that has been invested, everything has not solved that problem. And if you look at a little bit more, starting from this part of the world, there is a youth asking for new systems. Even I think that now it has gone into Europe. There is a way of going. All you have to do is to read the newspapers. And there has to be a change, because climate change, all those issues are worrying the next generation. So these are some serious issues, and that's why I have gone back even to admin, because even our university wants to respond to these changes. And I'll explain it with this simple example. In the third wave, we would have made a car chassis to go faster by making better engines, fast engines, even electrical vehicles. Now the question is, what is the point when you go out if the road is congested? What is the point of making a car going fast if the road is congested? You are just wasting. It's interesting. It could be your hobby, but why should the government and the taxpayers pay you to make the car go fast? Now what we need is a smart car connected with sensors where the traffic is coordinated and the flow is smooth. We may not need the speed, but we need that coordination, etc. That's where we are going to get the efficiencies. So this is the third wave skills. Fourth wave needs that system thinking and connections. Without that, the problems, SDGs, will never get solved. This is where the whole idea of socio-technical systems, everything is now emerging. And if you look at this, and the message here is, and this has got huge implications. We were training people to do a task, write code, write an essay. Yeah, AI will write the essay. AI will write the code. So why should we do it? Is that what we want? Or do we want a problem to be solved? This is an output. This is the outcome. Okay. That's food security. That's the water issue was solved. The traffic solution problem has been solved. Recycling problem has been solved. So we need to move from doing a task to completing a transaction, creating an output to creating an outcome. So that's very important. That's why I asked, with AI, if someone is writing an essay, you are doing a task. And in my class, I will actually deduct mark if they have not used AI for that. If AI is the best, let it do it. The question is, for the humans, can you create outcome? Can you solve a problem? It could be, some examples. There was a student group in one of the projects. One of the members' brother has particular disabilities. And they wanted to create an app to help that person to function in the society. And yes, they used AI, all that, but the outcome was a product, an app, where you can enlarge, look at it, for that student, person to effectively function in the society. And that is where the entrepreneurship comes. Then we should encourage them to take it, because that affects many more. Now you go and find the market. So there has to be a major, major shift in the thinking. So we are looking at AI native problem solving, systems thinking and complexity management, human AI workflow design, socio-technical system design, and AI governance, which was the issue you raised, AI governance ethics. It all becomes extremely important in the modern curriculum. And the key thing is, especially as it was mentioned about the new curriculum, the learning has to be anchored by real-world complex challenges. And we can do it, and we showed some examples. Yes, students will be doing data analytics, market readiness course, which Ruhuna showed. Yes, but they know where it is fit, why they are doing it, and how it builds trust. That is the understanding we need. And we can create environments like that to learn. So we should be looking at issues related to zero hunger, no poverty, climate action, project-based learning. And we create the fourth wave graduates and a systemic solutions. This is where we need to take with AI, though we showed all the tools, etc. This is the high-level thinking, which is a must. And that will solve not only in agriculture, in many more areas. So going back to one of my earlier slides, so the topic was digital technologies in agriculture. It all boils down to how we connect these 5 blocks to solve those complex problems. And as Ruhuna showed, if it is a user interface, AI will generate it. And we can check it, it will give the code, then somebody can take it and very quickly implement. So the speed at which we test these ideas is now gone up by many orders of magnitude by integrating with AI. So this is where the real challenge, how do you connect them at the system level? How do you connect them at the process level? And how we can make use of doing this. So if assessing this, yes, you should encourage them using the AI rather than discouraging. So that is the change which is a must. So what does it mean? And how did we get here? So if I reflect back on the journey we have taken over the 12 years with agriculture, we started with research. The earlier, yes, there was the overproduction of tomatoes. And we started how to solve it as researchers. That we found, though we thought it's a simple solution, it led to another problem, and another problem, and another problem. But we didn't limit it to the research labs. We started developing solutions. And we went to the field and worked with the farmers, and we tested it in the field conditions. We learned, we iterated many times. And through that, we learned, and now that knowledge we are using it to do the capacity building. And that's why this workshop comes here to share that knowledge, because that knowledge, what we generated, is extremely important. So it's an important part of our journey to do this type of capacity building programs to help the people. And then what happens is we get more people coming into research, into field work, into development work, and it's already happening. The students from universities, etc., they feed into the ecosystem. But it's more important is we do that now by making use of all these disciplines. It's not only agriculture, it's not only computing, not only business. We need all these disciplines to solve these complex problems. And we need to cut across the discipline boundaries, the traditional boundaries they no longer hold. This change has to happen. And all this needs to happen within the framework of systems thinking and design thinking. And what AI is doing is it is blurring these boundaries, because if I want to find out something in economics, I just do it. But I have no formal education, but in any of these, if you know your fundamentals, your mathematics, they are all optimization problems. With AI, you learn, and you solve the problem. So focus has gone from discipline to solving a problem, cutting across disciplines. And this is what the new curriculums should look like going into the future. All curriculums are dead, and this is where the jobs will be, or the new enterprises will come. So finally, I like to conclude this session. Digital technologies can assist us in building a sustainable digital agri-food futures if we think differently. And I think with that, we'll open up for questions, etc., so we can finish on time at 4 o'clock. So please, feel free to ask questions. I have given you a lot of information. Make best use of my presence. Yes. Yeah.
At one point in the presentation, it was mentioned a term fourth generation graduates. Fourth wave, sorry. I want to know the meaning of it. And also, again, when speaking about AI, shouldn't the humans have the basic capabilities of creative writing? Now, it is a task. Now, you said the task should be taken up by AI and we should go for problem solving. But without having the basic skill of creative writing, how should we see that whether the AI models are performing correctly or whether they are creative or not?
Thank you. I'll do it in the reverse way, because that's a constant argument we are having about the basic tasks. Because in a way, we take for granted these AI tools because we came through a non-AI upbringing, our learning. So we have a very good foundation of the way it works. And for those who understand how the AI works, we make best use of it in very short time. But what about the someone coming up now where they don't have the grasping? Now, the thing is, the fundamentals are fundamentals. We cannot skip that. The question is the way they should need to learn the fundamentals. I can now tell an example. Actually, it happened to one of my nephews. I think he was probably at that time 4th or 5th grade in the school. And there, they also have to learn, do some cooking. And they cooked some pasta. Then from there, the discussion went into where pasta is produced. The country is famous for pasta, Italy, and about Italy, the Italian culture, the eating. So it's a different way of presentation. If you look at maths, the way the maths being taught, mainly through patterns, and the way we sort of learn and the way they learn are different, but they both can solve the same problem, and they can solve the problem fast. But as educators, yes, we have to make sure the basic numeracy skills, the literacy skills, critical thinking, all that needs to be there. But on the other hand, if you really look at the time we spend on grammar, learning all that, I just put some quick dot points. The Grammarly comes in on my computer and suggests, okay, here's a better paragraph. Okay, I read and say, look, okay, sounds good. Press the button and it's there. So the tools are there to help, but first we should be able to express in order to make use of it. But it is a debate. I don't know the exact answer, how much of this or that. But certainly fundamentals are a must, and it should be there. The way we teach will evolve into more interesting ways. That's one, the first one. The second one is about the fourth wave. Now, about 60 years ago, an interesting book came out called The Third Wave by Elvin Toffler. And he analyzed the social transformation from the agriculture age, and even before that, agriculture age, industrial age, and the third wave was the information age. It was just starting. Now we are in the start of fourth wave, but he analyzed how social systems, the political systems, technology, all that interplayed, and as a result, how the organization structures. Why do we have hierarchical structures? Why do we have organizations? Like good old days, it was the Gurukula. But why do we have the universities today? Why we have this siloed subject and the discipline boundaries? It was required at a time. Again, if you look at Adam Smith's work, Wealth of the Nation, the specialization was a must. Because that was in a non-AI era. Access to information was a lot more scarce. But when it all has changed, we have to really question, do we need these silos? Or do we need to concentrate on solving problems? Do we have new tools to do it? Say, we have a big tree to cut. We can try to do a hand saw and try to cut it, or use a power saw and do it in much less time. So when things have changed, the way we work has to change. So a fundamental change has happened with generative AI. Up to this point, information was always came from the humans. They logically worked out rule-based engines and generated some new information, but again, it was there in the original, it was highlighted. Now, for the first time in the last 2.5 years or so, the machine was able to generate information based on statistical models. So the machine thinks in statistical models, not in the way we think. But it has changed the productivity by orders of magnitude. That's what I showed some examples. When that happens, can we keep doing the old things? If the industry wants people who can produce, and if the person is working in the old way, will those jobs survive? That's why exactly I asked that question. What jobs will be there in the future? These jobs are there, but the way it's done, the way the problems are solved is very different. And the things where a big team is required, now 2-3 people can get together and do that. So those, if you can solve the problem, that has value. And if there's value, someone will pay for that value. If you can't identify the value, that's why earlier stressing on the value, then they will say, look, I don't want it, because there's no value. So there has to be a major change. This may be a big shock coming as it, but please reflect on it. And with time, and with all the other things happening, you can reflect back onto this particular workshops around AI, etc. It's not just automating IoTs, etc. The big problems, food security, sustainability, climate change, they are all linked to these disciplines, and we'll need to think differently. Any more questions, comments?
I'm a little bit curious about the thing is that, so undoubtedly this AI is doing marvelous thing. But now we are actually, as we discussed, that the students increasingly intensively using these AI tools for their assignment and all that. But my concern is that sometimes for some special type of question, like something like engineering design, for some critical issue. That is kind of innovative things, or that is that seed of thinking, maybe something very critical, is coming innovative ideas. A seed of innovative ideas, probably spontaneous, and those are irrational, not going with the stream, opposite the stream, out of the box. So will that kind of ability in the human being will diminish with this type of AI tools everywhere now? People are, the brainstorming is reducing drastically, and people are just, they input their questions, and then the AI will search and try to get the solutions. But sometimes some points, like engineering design for a particular issue, because I have a practical example for that. So when I have some question, some designing tip, the requirements, sometimes maybe the solution comes spontaneously, rationally, and impulsively, and that is completely something new. So haven't been imagined before. It's completely new. So what do you think that that ability will be affected?
I think that ability will be amplified. Simple example, like the startup Vidya. We are in multiple countries. We don't have physical meetings. Every week we meet twice, Zoom. But now with AI, a few minutes after the Zoom meeting, we get the transcript, what was discussed, summarized. That goes to a person who loads it into a system. And every morning, an email comes, what task are you working on? And here are your ideas, and all the ideas get documented. So the work patterns have completely changed. And then the other thing what Ruhuna showed you, we whiteboard, we discuss the ideas that comes. And moment it comes, and when we have that, take a picture, upload, and it gives the transcript, and then we build on it. And sometimes they leave that diagram on my whiteboard without erasing, because when they come, they will see I have annotated in few more times this, what you just said, the spontaneous, the image, get you to annotate it. And normally they say, look, no, I'm not going to delete it till someone comes and delete it, because they find it, I have annotated it, if I had some ideas. So I think I see AI as a double-edged sword. If you hold it from the wrong side, you are going to bleed. If you hold it from the right side, it's a very, very powerful tool. And this is where we have to teach, like how we teach a child to use a scissor safely, how to use it properly. I think that's, I feel, as a responsibility of us as part of that new education. But that what you said, it amplifies. Like when I get some ideas, I'll put some dot points before I go to sleep. And next morning, I have a fairly detailed thing. Then I interact. Then I share it with others. They interact. The idea grows, and it also nicely document. So in other words, the transition from our tacit knowledge to explicit becomes much easier if you know how to use these tools. Those ideas are where the value is, those specific ideas.
The possible design we can request to
The form. Yeah.
Sometimes, maybe 99%, so that those things will be going with the same flow.
Yeah.
Sometimes some kind of special type of design probably generate human mind.
Yes. Yes. It's very true. Yeah. No, it has to be. This should trigger our thinking. We cannot rely on it. The moment we rely on it, we become a slave to AI. No. Yeah, that's why I said it's a partnership. We need to learn how to make best use of it than being a slave to it. That's very important. Any more questions? So we have a few more minutes, I think, for questions. Sorry? There's some questions. Okay, we'll try that. Yeah.
The software exercise just before the lunch.
Yes.
We answer the question.
Yeah. Oh, okay. Let's see what is there in the Mentimeter. Probably I'd like you all to respond to this question. I think as a summary, as a report, if you all can please respond to this question, what are the key three new things you can learn today that you learned? I mean, based on that, it will give an idea of how much of this being absorbed. few answers in the next 3 minutes, then we will do AI summarization to identify the important themes. So we have 35 out of 81. Any more going to submit before I do the AI summarization? So 1 more minute and then we'll summarize. Just to see what the trends are. Okay, let's quickly summarize and see what is going to tell. Many of you have picked up about AI tools. Yeah, we were debating how much you all were aware of these tools, though it's freely available, but it looks as they are quite new here. Notebook LM16 responses, Google Studio. It's another AI tool about the digital technology, 3 responses, research applications, 2 responses. Okay, that gives an idea of what has been picked up in this session. And anything else we need to do, or but I think it's more of going forward how you utilize all this, whether it's in your research, teaching, but also looking at what the society needs and looking at solving a problem than doing a task. I think those are key things. And a lot can be done in agriculture, a lot. It's not like anything else. If you want to buy a cloth, you can delay it by a week, 2 weeks, 3 weeks. But if you are hungry, you need the food now. So with that, probably I'll conclude and hand it over to you.
Thank you, Professor Ginige, for that stimulating and hands-on sessions. Your generosity in sharing the full day of expertise with us has been invaluable. To formally recognize his immense contribution and his generosity in sharing his expertise with us, it's now my distinct honor to invite Dr. Avanti Mahanama, the head of the Department of Agricultural Engineering and Environmental Technology, to deliver the token of appreciation to Professor Ginige. And now I cordially invite Dr. B.M.S. Jinendra to deliver the token of appreciation to Ms. Tilina Kumari of National Science Foundation. Our dear participants, we value your feedback. Please scan the QR code displayed on the screen to share your insights regarding our today's workshop. As we draw this enriching workshop to an end, we will now hear the final reflections from Ms. Tilina Kumari, Senior Scientific Officer of National Science Foundation, to deliver the key takeaways and closing remarks. Over to you, Madam.
Right. Thank you, and I won't take a lot of time as the subject content was well wrapped up. I mean, as the concluding remarks or as the take-home message, what I captured was that there's an immense opportunity for the academics of this faculty and also to the grassroots levels and for the entrepreneurs, perhaps the students, to get together and to work towards developing technologies to incorporate the digital technologies into the agricultural ecosystem towards achieving impact. So there were a lot of research avenues which could be workable towards industries which were mentioned throughout the day-to-day. So I would like to invite you all to work together as a community in collaboration with our expatriate eminent scientist, Professor Ginige, and his team to develop some technologies, and where possible and necessary, National Science Foundation would also consider the requests at a competitive and through our grant schemes. So we are always there to facilitate and coordinate for the betterment and to achieve impact. And I hope that this exercise will be fruitful by implementing such steps as extensions. So please do work towards that end. Thank you very much.
Thank you, Ms. Kandanamulla, for your valuable insights. Ladies and gentlemen, today has been a testament to the power of collaborative innovation. Our deepest gratitude goes to Professor Athula Ginige for being with us today. Sir, your presence has elevated this initiative immensely. We extend our sincere thanks to all our dignitaries, moderators, and every participant of your vibrant engagement, and the organizing committee for their incapable execution. You all have contributed to making this workshop a resounding success. With that, the workshop on digital technologies in agriculture, bridging research, teaching, and practice is officially concluded. We look forward to reconnect with you at our next collaborative series. Thank you very much. Stay safe and have a wonderful evening. And we have arranged you some refreshment. Please enjoy it and join with us for the photo. All the participants, please come to the entrance of the